I'm currently pursuing my Executive MBA at Africa Business School of Mohammed VI Polytechnic University, which focuses on some of the pressing challenges facing the African continent. This program, which is truly transformative, is designed to prepare the next generation of African leaders who are culturally aware and socially driven.
Distinguished guests, ladies and gentlemen, welcome to all of you. Please take your seats. We will be
J'ai la chance de participer à l'exécutif MBA de l'Université Mohammed VI Polytechnique et surtout la chance d'avoir accès à une formation de qualité internationale fournie par des professeurs reconnus mondialement. L'objectif de l'Africa Business School est de former les futurs leaders africains. Car en fin de compte, l'Afrique n'est pas seulement une source des ressources naturelles ou de la main-d'œuvre à bas prix, mais surtout, demain, le contributeur à l'excellence académique, scientifique et business au niveau mondial.
أصحاب المعالي سيداتي سادتي السلام عليكم ورحمة الله. Excellencies, distinguished guests, ladies and gentlemen, on behalf of OCP Group, it's my honor to welcome all of you to the 4th International Symposium on Innovation and Technology in the Phosphate Industry. Welcome to Africa for those who are coming from other continents. Welcome to Morocco, to more than 900 delegates from 43 countries. And to all of you, a warm welcome to Ben Gurir. Thank you for being here. My name is Yasser Tazi, and I'll be your MC for this opening session. Please, would you be kind enough to turn your mobiles on silent mode, and thank you in advance. I now invite you to watch a short film on the commitment of OCP towards innovation to participate in feeding a growing population by providing essential elements for soil fertility and plant growth.
The world is changing.
Love it. Test. Hello, it's the first day of SYMPHOS 2017, and we're so glad to be here at the.
I think OCP deserves a round of applause for what they're doing. It's my pleasure now to invite for a welcome address the Managing Director of OCP, Mr. Mustafa El-Wafi, if he would join me.
Ladies and gentlemen, dear SYMPHOS participants, after a successful past 3 editions in 2011, 13, and 15, it's a tremendous pleasure to warmly welcome you to the 4th edition of the International Symposium on Innovation and Technology in the Phosphate Industry in UMCSP, University Mohammed VI Polytechnic. This university, which just recently had the honor of an inaugural visit of His Majesty the King. As you may know, the university was established by OCP Foundation, demonstrating OCP's strong commitment for science, innovation, and research and development. Would you believe that such place is the ideal and nice place to host SYMPHOS community? We are extremely happy to see the SYMPHOS community growing. We are honored and grateful to see such large audience and attendee for this 4th edition. SYMPHOS is the innovative phosphate industry forum, offering a rich technical program and gathering a valuable participation of world-renowned experts, scientists, researchers, engineers, professionals coming from different horizons: mining, chemicals, agriculture, products manufacturing, and equipment manufacturers. If you take a look at the SYMPHOS program, you will agree with me that this symposium is going to be busy and hopefully very productive. There is a lot to offer for a 3-day event. I would like to take this opportunity to thank the participants, especially those of you coming from abroad, for joining us, sharing your valuable experience and ideas. The latest technology and scientific knowledge in various fields in relation with phosphate industry will be discussed throughout the 3 days in plenary sessions, keynotes, thematic sessions, conferences, workshops, and B2B meetings. A total of 22 themes are proposed to the audience, which will discuss and cover all the value chain, from mining, beneficiation, fertilizer efficiency, energy, and agriculture, of course. More than 100 exhibitors are present, and they will be presenting the latest of their technology, the best of their know-how, and their innovative products and services. I hope this edition, SYMPHOS 2017, will be an unforgettable experience for each participant. I am honored to participate in this incredible event. We are all here today because we have the same objectives and ambitions. All of us have to make of this event an opportunity to share knowledge, innovative ideas for sustainable development progress along our passion for phosphate industry, learn from each other's experience, and to create a community of interest, of challenge we all have. Thanks to you for your participation and involvement. SYMPHOS was a great success in the past 3 years. This year, which means 11, 13, and 15. This year, we look forward to amplifying this experience and taking it to a new height to build an active worldwide community of practitioners driven by the desire to promote innovation and technology for sustainable development. Challenge for all of us is to be innovative. We are thankful for you, for your presence in your University Mohammed VI Ben Gurir, and hope you all enjoy your stay in this beautiful region of Marrakesh, and also your stay in Morocco. Thank you.
Thank you, Mr. El-Wafi. Ladies and gentlemen, it's my pleasure to invite the chairman of Mohammed VI Polytechnic University that is receiving us, and I invite Professor Driss Wazar.
Ladies and gentlemen, good morning. On behalf of the scientific, technical, and administrative staff and students of our university, I am very pleased to welcome you to this 4th edition of SYMPHOS Days. It's really an honor and privilege, and we would like to thank OCP for hosting such an international event in Ben Gurir. UM6P is a new kind of university, and His Majesty the King has honored us by kindly giving it his name. It is a land-grant, not-for-profit university of public-private partnership with the Ministry of Higher Education and Research, which promotes academic excellence with special emphasis on challenges facing the African continent. OCP has incubated this world-class university to foster a wide educational and research innovation ecosystem around multidisciplinary areas in engineering, science and technology, business, economics, humanities, and social sciences. Its missions are smart, sustainable, and inclusive applied research and development and dissemination of research findings. Provider of knowledge-based technological solutions and services to satisfy the needs and to face challenges of OCP, the industry, and society. Contributor to improve and shape the national industry. helper in building national and African capabilities in science, technology, humanities, management, education, and research. Special initial focus on OCP activities, vision refinement, and continuous improvement. In parallel, I am pleased to announce the launch of a unique master program entitled Fertilizer Science and Technology in collaboration with IFDC, to which other international partners will contribute. The university research teams are built on research strength aligned with the national strategic research priorities, taking advantage of the OCP unique regional footprint while being open to Africa and the world, such as phosphates, which is the main topic here, nexus, water, energy, food, environmental sustainability, complex engineering, and human systems. UM6P will host and develop OCP research and development innovation agenda covering, amongst other, value chain performance, innovative products, utilities management, industrial strategy and economics, beneficiation, tailing and mining wastes, geology and mining. UM6P constitutes a bridge between industry and academia, thus creating a continuous open dialogue and synergy to infuse valuable knowledge to OCP through customized educational and research programs. By developing new products, new technologies, and innovative management tools that will empower the society within the framework of sustainable development. I wish you all a successful conference and exhibition. Have a pleasant stay in Morocco and in our campus. Thank you.
Thank you, Professor. Please allow me to introduce our first plenary session, Innovation for Sustainability. Our keynote speaker is Professor Sriram Ramakrishna.
Love it. Test. Hello, it's the first day of SYMPHOS 2017 and we're so glad to be here at the Mohammed VI Polytechnic University in Ben Gurir and all over the world live with you on YouTube, LinkedIn, and of course Twitter. We'll be live all day today, tomorrow, and Wednesday. So don't hesitate to follow us, to listen to our streams, and to tweet at us using the hashtag SYMPHOSLive. SYMPHOSLive. Thank you very much. And now let's talk about our first plenary session that's taking place today, and it's gonna be presented by Professor Sriram Ramakrishna, and it's about innovation for sustainability. It's of course a big theme for us here in Morocco, because innovation used to be for only the happy few, the lucky few, but now it's for everyone because sustainability is necessary for absolutely everyone. So during this lecture, we're gonna hear about innovation in manufacturing, in energy, water, materials, as well as transportation, mining, agriculture, and the food business in general. So let's go and let's watch this presentation by Professor Ramakrishna. And once again, do not hesitate to ask your questions using SYMPHOS.
Excellencies, distinguished guests, ladies and gentlemen, good morning. If I had to give this lecture in Singapore, I would be telling you good evening. So that's the time difference between Morocco and Singapore. I'm thankful to the OCP as well as SYMPHOS Organizing Committee, RISDIBA, for inviting me over for this opportunity to share our thoughts on innovation and sustainability. most of you would know innovation, sustainability are very large topics. And I'm a professor. What would happen? I will be giving the lecture till end of the evening, right? Yes or no? You are very serious. Right. So you want that? No. So, right. So what I'm going to do is I will take about 35 minutes or so, take you through some important slides. You have a copy of my presentation. You are more than welcome to see it at your own leisure time. At this important occasion, I also would like to congratulate OCP for incubating this particular university to become world-class university. This is exactly what we did about 20 years ago in Singapore. My presentation will actually take you through how this happened and perhaps something that we could have a mutual learning. So I hope that's the objective of this presentation, focusing on mining industry, at the same time, the broader context of innovation and sustainability. I think the best way to start is with this slide. I like that Moroccan mint tea. And more interesting was this gentleman, the moment I said I'm from Singapore, he actually told me more about Singapore to me. So he's so familiar about Singapore. I have noticed a number of Moroccan people, I think through your media programs as well as your own family members, you had exposure to Singapore, which is very nice. I feel very happy and privileged, and you're all more than welcome to visit our country. Also, I'm not sure whether this student is in the audience. I think he looked up the program and then he saw my name. He shot the email. And then I read his email. It was clear to me that OCP is thinking quite forward, and you've already been looking at harnessing renewable energies, which is brilliant. So I'm going to look at a mining sector at the same time, innovation and sustainability. Oh, well, that's not Morocco, that's Chile. I was there about 2 weeks ago, visiting Chile copper mines. So I was invited to have a strategy discussion about innovation. And you might know this gentleman, he was actually in Marrakesh for COP22. And he was actually explaining, Alejandro, he's the head of the investment agency in Chile, and he was explaining how green mining is being pursued in Chile. Take a look at that one. Just like Morocco, the largest producer of phosphates, Chile is the largest producer of copper for the world. And if you notice, they said they are going into renewable energy. They have invested. Right now, they have a 500 megawatt solar power plant. The plan is to go up to 1.2 gigawatts in Atacama Desert. And of course, they're also looking into aspects like a digitization of mining, autonomous vehicles, electric vehicles and batteries, IoT, nanotechnology-assisted mining, and water treatment. So some of these topics, actually, I would be covering part of my presentation. So that's how we link to what is the interest of Morocco as well as OCP. Why innovation is needed? Because solar PV technology has been there for quite some time, more than 30 to 40 years. Still, there is need for innovation. Here is an excellent example. Chile had set up 400 megawatts plant already, but they're having some other technical challenges. It's an Italian technology. And the reason is, if you notice, if you notice here, they have a UV radiation very high. And because of that, the modules have a shorter lifespan. So obviously, technology might be established. You still need innovation because the conditions at which this technology is deployed could be different. And I say that from observing the sun, of course, we all observe, Let's see. Do you recognize the face there? Looks like me? Yeah, that's right. I'm younger now, right? Okay. So this was about 10 years ago. We established a Solar Energy Research Institute, and I was the founding chairman. We spent about $120 million. And the reason was we have no solar industry in Singapore at that time. But we felt, as a strategic energy independence, Singapore needs to go into the solar energy. And I could go into the details if you are interested, but fundamentally, we established this one. When we established this institute, the issue is we had no human capital who are actively involved in a PV technology. So I actually hired Joachim Luther. He was the head of the Freiburg Solar Energy Institute in Germany. So when we hired him, he basically said, why would I need to come to Singapore? I told him, I give you $120 million, and we'll have an industry to work with. But we had no industry. At the time, we went to Norway, and we got Renewable Energy Corporation to invest or bring the technology to Singapore. Right now, happily, after 5 years, we have worth a $4 billion industry, which is actually built in Singapore, REC. And this institute, Solar Energy Institute, provides the innovation. So this conference is about innovation and sustainability. Solar energy is sustainable technology. Innovation is you structure research institutes at the universities, what we call corporate labs at the National University of Singapore, and we work on industry-defined problems. Just as this university being incubated by OCP is an excellent way to pursue that strategy. And of course, we are looking at low-carbon solutions and innovations via collaborative research. That's basically the strategies we have done. Happily, within 2 years, we have more than 120 high-quality research scientists in one place. Really, it has kickstarted the whole program. We have the whole industry now. We're one of the major players in this area. And you look at it, how is this addressing Singapore's own needs? Singapore, I will later on give you the details. We need about 6 gigawatts peak electricity capacity. And our plan is to build 4 gigawatts of, that is almost 80% of the national electricity need, by what we call floating solar farms. Singapore is a very small place, but we are an island. We have access to the sea. You can imagine more like a Casablanca. So the question is, can we have the solar farms built on the sea, but delivers electricity to the country? And that's basically the plan, and we're on our way, and that's about 4 gigawatts. And then you do a lot of technology and innovation in that area. So again, it's very much customized to the needs of the country. Okay. Well, I think I'm not going to tell about Morocco to the Moroccans, because you know that. But me coming from abroad, I still need to have a sense of it. Of course, you are the players for the phosphate industry for the world. And of course, it goes into many aspects of the daily life. It's common. So what I intend to do is I'll take some of those and try to show some of the innovative technologies that are coming up. So that's the way I bring the aspect of innovation into the kind of work you are trying to do here. And sustainability theme is picked up. We just celebrated about a few weeks ago, the World's Sustainability Day. And these are the issues which you can actually find them in a literature, scientific literature, which talks about some of the issues with the phosphate mining, which you are all very familiar. You would also note is from this, what are the options you might have in terms of moving forward, where you could introduce sustainability concepts in the overall supply chain of mining industry. But I could probably add a few more things. That is how you can integrate renewable energy technologies that are coming up, automation, electric vehicles, batteries, nanotechnology, water treatment. Again, there's a whole range of other what we call adjacent innovations, which could be integrated into your grand plan of making the mining sector sustainable. So there's some of the ideas which I thought I can share with you. So this, I would not go into that because I said I want to go forward so that I complete within the time given to me. And this is your population. That's how they're becoming literate, which is very essential when OCP wants to incubate this university to be innovative, as well as set up a lot of startup companies, high technology startups. So I think that's the background I looked at. And that's what your plan is. Let's compare now Morocco and Singapore. You have 35 million population. We have 5 million plus population. Our GDP is about $300 billion, and you have about $100 billion GDP. If you look at per capita income, we would be about 87,000, and that would make us top 3 in the world. So that's basically the scenario of Singapore. And Singapore was a fishing village 50 years ago. So 50 years ago, it was just a fishing village. All right, so I'll take you through what actually has happened. Okay, that's basically, it's me, a robot, talking to you. And then that's Singapore and the National University of Singapore. I'll give the introduction, then I jump into some of the innovative ideas. This is the National University of Singapore's engineering school. We have about 10,000 students. I was running it as the Dean of Engineering. During my time, it became the top 10 schools in the world. If you want to know how many engineering schools there on the planet, there are more than 10,000 engineering schools on the planet, producing 2 million engineers a year. So that's the level of capacity that's being built around the world. So we were very happy that this became among the top 10 in the world. And this is the university, my university. It's number 1 Asia. Asia would have about 6,000 to 8,000 universities, and National University of Singapore is now number 1. And in the world, it would be top 12 in the world, according to the international rankings. Not by our rankings, by the international rankings by different agencies. And if you look at how this university became so prominent in a shorter period, is we took the path of internationalization. And I was asking how this institution, where we are right now located, how are you recruiting students, and how are you recruiting faculty members, how you are incentivizing research. Most of the things I heard are pretty much you are in the right direction. That's exactly what we did 20 years ago or 10 years ago. So I think what you told me is music to my ears. And of course, there is some other ranking called innovative universities. We would come as the top 11 in the world. And this is our patent profile, how actively we file patents from the university. You see in the last 10, 20 years, high trajectory of patent filing. And of course, we also established a big funding to promote innovation, not only by ourselves. For example, in this university or in Morocco, there is a startup that wished to go to Singapore that would be facilitated, and vice versa. So I think this is again where this institution can explore how to establish transnational partnerships, especially in Asia, Far East, where we would be very open to have such an arrangement. This is a structured program. It's already happening. So this is how we think innovation can be promoted, because we ourselves may not have all the tools and abilities. By having a global partnerships, you promote innovation much faster. That's the concept behind it. And you can see Singapore is a top 12 spot in terms of tech startup ecosystems in the world. And then now coming to actual Singapore in terms of the size. Singapore is located here. That's a big country, Malaysia, Indonesia. We're a small, tiny dot, 700 square kilometers. Probably that size of Marrakesh, I have a feeling. Maybe Marrakesh is probably bigger, right? So we are exactly the size of a small, tiny island, about 5 million people. And we are one of the densest living places on the planet. Most people live in the sky because of the tall buildings. There's not much land mass that is there. And that's what it is. And so when we go back in 1965, about 50 years ago, there's no energy, no food, no water, no natural resources, no scenic nature either. You have a fantastic scenic nature in Morocco, Marrakesh. We had nothing actually, except just a fishing village. And fast forward, it has moved completely. It has transformed. We also joke actually. You see here the flying wheel. Yeah, sorry. We always say London has the eye, and this our wheel is about 1 inch bigger than that one. We say that. I think they figured out we need to have at least 1 inch bigger than London one. So that's how it goes, right? That's the one. That's a new addition. If you had been to Morocco, say 10 years ago, you would not have found that. Now it is there. It's a beautiful place to visit. Okay, that's how it looks like. That's the skyline. And you see this is the tallest buildings. We have a ship on the top. More important is we are a trading nation. So our trade volumes would be about $1 trillion. And we have $100 million companies, about 2,000, and that's numbers. So, and one more detail probably I can give you, the total foreign exchange in the world in a day would be about $6 trillion. Singapore does about $0.6 trillion foreign exchange. So that's the amount of involvement on the global activities. Okay, that's pretty much. And how do we make that money? So we have, just as you, some of the heavy industry. And here, chemicals and oil refining, marine offshore. Recently, we moved into LNG, which is a large sector. And then, of course, finance and aerospace. Okay. The purpose of this slide is we know Singapore is small and the world is big. There are lots of big countries. So we see ourselves a tugboat. The world is a massive shipping liner. You really can't influence it too much, but you could adjust it a little bit as a small nation. So that's pretty much the mindset of Singaporeans. So this is how it works. Okay, so how did we do that? If you notice, I began saying in 1965, we had nothing, but we have human beings. We have lots of humans, well, at least 2 million people. So we invested in human beings, and you should see, okay, let me get that one. So what we've done is we steadily invested in scientific research and innovation. That's the innovation in, okay, let me show you. In terms of the perspective, number of research scientists and engineers per million population, Singapore will have about 6,500, which makes it the highly dense research and innovation ecosystem in the world. So that's the way to invest it. And if you look at the numbers, if you notice here in 2000, there are only 5,000 research scientists and engineers. Fast forward 15 years, 16 years, we have 50,000 research scientists and engineers in one single location. And there are about 3,000 women PhDs. So that's another important human capital. So we now spend close to $19 billion on scientific research in a period of 5 years. And these are the sectors where we are investing. I'm one of the advisors for this investment strategies, why we choose certain areas. Here is an example. One example is to build Singapore as a smart nation. And these are the articles I wrote some time ago. I also appeared in Scientific American. It's basically smart nation. make use of the digital technologies and make the country as smart as possible. What it means, basically, there's lots of areas, but for you, for example, in the transportation sector, for example, waste management sector, water treatment, delivering energy, all this requires these smart technologies. So we are investing lots of innovations that are being test-bedded and integrated. Okay. Just give an example because you have an interest in shipping. And if you notice, leading maritime capitals of the world, and in shipping, finance, law, maritime technology, logistics, and overall rank, Singapore would come number 1. Maritime, shipping, it's a number 1 country in the world. But we can't stop there. So we got to move on and build the futuristic port. Here, we're talking about applying digital smart technologies to make the port operations as autonomous, as intelligent, as smart as possible, so that you can increase the volumes, you can increase the efficiency. So you're basically integrating lots of innovations. So here is the smart port concept, and you could see how they are being deployed. Yeah. If you want to know, for example, we don't work in isolation. Take an example here. Recently, International Maritime Organization said the sulfur content in your fuel for the shipping lines cannot be more than 0.5%. So what we did is we came up with a technology guidance document, what we call TR reference. This is the international standard. So we actually involved in shaping the international standard so that we can play a very active role. So you could see here is an example. TR for LNG bunkering. Remember, we have no LNG. There's no gas there. That gas probably coming from some other countries far away. But you can still do a lot of things even though you do not have the resource. That's just an illustration. Okay. So the other one we are investing substantially is a smart manufacturing. And you could look up this article which we wrote. I'll be very clear. There's a lot of details. So basically, smart manufacturing involves a variety of these technologies, and you are linking to the Internet of Things. And I've seen some of the presentations at this conference. You are going to talk about IoT in mining operations, which is very good. And we go from there. We're also looking at what we call a zero waste or a low carbon manufacturing, and that's how you look at it. And basically, this is how we define what we call zero waste manufacturing. So we are now developing systems where several industries, waste of one industry becomes a resource for another industry. But it requires a lot of information sharing about the waste because the waste characteristics are not uniform and the volumes and quantities availability is also not very well defined. So you need all that information to make this a very smooth, seamless operation, what we call industrial symbiosis. Again, it's a waste management. You link up the modern technologies. That's innovation. Okay, so I won't go into this one, which is what the field I champion, what we call materials informatics. I'll just tell you what we can do. This is a web-based materials informatics where you are looking at designing materials for the environment. So you don't just take the material, you design the material for the environment in mind so that you actually make the products with the environment in mind. So this is the latest technology you can think of in materials research. And this is how we do the designing for the environment. And we are also now getting into vertical forming because Singapore is a city, but we felt that there is an opportunity for vertical forming, a lot more automation. This is where your phosphates, which goes as a fertilizer, you have a much more controlled environment. Perhaps you can enhance the recycling ability. So this is someone can think about that. Yeah. So the urban forming. Okay. Again, I just want to remind I'm still around. It's me. Yeah. and I do talk about innovation. Right? Just a proof for you. Right? No, because the reason I'm showing you is we are thinking 50 years from now, how Singapore would be. Well, we had 50 years before, but we also had to think about 50 years ahead. So they think nobody knows the future anyway, but at the end of it, as a professor in the university, all I could do is I can say, okay, this is what I think. Let's see what happens in the future. If anybody has a doubt, you know what I said? At the end of it, let's meet in 2065 and check it. You think I will be around? Probably not, right? Okay. You are hoping that I will still be around, right? Okay, I had to be 100 years by that time. Let's see. Okay. So this is happening in Singapore on the bigger backdrop in Asia. You look at what's going on. China, US, EU, India. This is a projection by IMF, where these countries are heading in 2050. So we are in a region highly dynamic. And I'll show you how dynamic it is. You look at R&D spending, the world's R&D spending. Now, China is actually going to overtake, in 2 years, United States. That's the level of investments going on in Far East. So those are the numbers for you. And you see that this is basically, if you rearrange that information, how it looks like. So which are the top performing countries in research? What I want to say is, the world is spending about $1 trillion on research and innovation. 1 trillion. So I think, again, a message here is Morocco is taking the steps, and I think you could do even more in this direction because innovation is moving very fast. Yeah? Okay, so why is necessary? Why Singapore also invests in research is the multinationals prefer to work with places, not only tax benefits, they also want to find places where they can harness innovation. So here, this is what is the trend, and importance of quality universities, which is exactly OCP has taken the strategy to establish this kind of world-class institution. Yeah. Huh? Well, okay, I have a Q&A. I'm going to answer that one. Yeah, sure. I will definitely answer that question, yeah. I'm not sure how much time I have. I would want to first finish my presentation. I'll come to you, yeah. Okay, so just, I know some of you are professors and students here. Just get the context right. Not a long time ago, at the beginning of Industrial Revolution, if you notice, very few journals move forward 300 years, or last 100 years, or last 50 years. Actually, you'll find the millions of researchers and patents, 11,000 journals, and 1.5 million papers a year gets published. That's research. And that's what is happening globally. Look at the scale. And some of us, I think you must have seen this movie, Star Trek. Yeah? You identify this guy. Of course, this is how you look like. So writing research papers sometimes can be very tough. By the time you write your paper and get it published, some of us most likely get to that situation. It's very tough. Well, I tell you the other numbers. You look at research, inventions, but actually converting them into viable businesses is also not easy, very tough. And especially the investment groups, they would ask you the hard questions, and that's where the difficulty comes in. They want to see the evidence before they invest. So this is where the chicken and egg situation. So you could see that. But it's not everything gloomy. In fact, there is hope for every one of us. This is the international compilation of average age of the most prolific inventors who file patents. And what is their age? Good news is, Most of them are in 40s to 50s or 60s. So there is still hope for a lot of people here to be much more dynamic and file lots of patents, do innovation and invention. This is the global average. And if you don't believe me, I would have to show a real example, which has relevance to OCP, definitely. It's a lithium-ion battery. This guy, John, when he filed the first patent on co-invention of lithium-ion battery, he was 57. Actually, most people by 55 started thinking of retirement. He's 55. It's amazing. Just a month ago or 2 months ago, at 94, he filed another patent. And of course, he says it's a game changer for the battery technologies for the large vehicles. So I believe one side is tough, the other side is also quite promising. So it requires a bit of a different mindset. Okay, this is now, I'm just going to jump into this because this is my own research, but I wouldn't go into the research because it's a broad audience which have a diversity of interest. But I'll just show you, for example, lithium-ion batteries. You look at anode material, which is dominated by carbon, and then these are other materials, and then cathode materials. You have a lithium iron phosphate, which is relevant to some of you. And this is the performance, and you could see this is the lithium copper oxide, lithium iron phosphate. Well, with innovation, you can drive the performance higher. Right now, for example, you have a battery energy density, which is about 130. How can we enhance it? So this is where the new innovation, nanotechnology comes in. So here is more details. With my own technology, which we did, what you see, nanotechnology, what we call electrospun nanofibers for cathodes. This is the Sony battery. The other batteries, A123. If you make these in a very fine fibers, you change the way certain things are happening in the battery, electrochemical reactions. Fundamentally, you're not changing them, but you are changing the kinetics. And then that delivers you a better performance capacity and a cycle number, okay? So this is basically to show you the technology. The basic concept, I use what we call electrospinning, and that's how we produce fibers. We actually build the machines, so not only technology. So if you notice, we build the smallest machine, the size of the pen, so you can put in your pocket, take it. And we also build the large-scale industrial machines. These are meant for large corporations like OCP. So we span our research from the small end to the high end. So that's what we do. This is my own research. I know some of you have doubts, so just I prove myself again, it's me in a different dress. Yeah? That's it. Okay. Okay, there's just more details. I just want to give the backdrop on that one. So if you look at the lithium-ion battery technology, there's a demand for making a bigger systems. There's a lot of drive. For example, Tesla, which most of you know, it's the most valued company than GM and Chrysler. Right now, most valued company. But what is Tesla? It's a battery company. It's not a car company. It's a battery company. If they don't have a good battery, they don't have the future. So, what is battery? Lithium iron phosphate, right? Well, at least one of that. So there could be other things. Okay, so here is an evidence, China. I go there very often. In fact, after this visit, I'll be in China. This is how in Qingdao, they're producing electric vehicles. And the companies tell us there is still a lot more innovation is needed in the materials, system integration, and deployment. And of course, these companies are investing 5% of the annual revenue on R&D. So that could be one. Maybe small, but a good startup. Okay, so again, you look at the big picture. You look at here, China and India are mandating electric vehicles to be made a fraction of the total car production in that country. So they're actually mandating. So that's a huge policy push. So that means they're changing the transportation sector. You could see that happening already, right? And this is the volumes of the manufacturing by different companies. Okay, so what else is happening in that automobile transportation sector is it is getting to be more electrical, connected, shared services, and autonomous. Now, the reason it is autonomous, you may not realize it because you have a young population here, but you get to the countries like Japan, China, there's a lot more people who are above 65. And if you look at the car accidents, number of car accidents, that's related to the age. Most of the time, when you're young, there's more accidents. And you're also, when you're getting to the other end of the life spectrum, they tend to be higher accidents. Now, that's the motivation, driving automation. Assisted driving. So this is what is happening, why there is a push. Okay, so that, on top of that, you envelope it with heating, cooling system, electricity. You want to drive the smog out of the cities, like Singapore, Hong Kong, Beijing. There's a lot of smog, and that need to be clear. That's why you go towards electrification. So now I just jump. This is other research we do, cabling. And you could see these are the cables, and you see how heavy, how big, how long these cables are. Can we actually innovate? And what we do, we work on a system. Let me show you. We work on what we call carbon nanofibers, carbon nanotubes, very fine, tiny. You actually can't see with the eye, but they're much more lightweight. Can we now use them to partially replace copper so that you save weight from 8 to 1? So the enormous saving in terms of the weight. Can you imagine offshore exploration? The cable sizes are maybe 3 kilometers or 5 kilometers long. It's very heavy. So you need that kind of innovations. So of course, that is a longer vision. You can take those ideas and we put them into what we call, I just go into the technology side, what we call wearables. So basically, we take the small bites in innovation. So here is the wearable technology. For example, my shirt or my coat, if I have this smart technology, when I shake hands with you, you more or less know me. And I also know you. Isn't it fantastic? Right? So that's where it is going. So we integrate our concepts into this. And again, there's a proof. Yeah? Okay. Yeah. So, but the issue is, how do you make them washable, drapable, these fabrics, once you integrate all these wearable technologies? That's still an issue, which is what we are looking at. And here is an evidence, for example, a guy, he actually can open a door with a mobile phone. There's no special arrangement. So here is the proof that was just published. And the human body is used for electricity transmission to do these wearable technologies. Yeah. So this is the proof of concept. Okay, so you can also see we produce electricity from the human vibration. And you can also make different materials, different colors. So you can have fabrics, just not monotone. You can change the colors. So this is how the innovation comes in. So fundamentally, I believe innovation happens with the progress that's happening in other fields. In this case, you see, I came across, it's not our innovation. They call, normally we drink water. These guys are making you eat water. Now, most of the concepts are already there. It's just they integrated, it's just a new innovation. So that's basically innovation. You can call it adjacent innovation, okay? So in summary, I would like to say, well, OCP perhaps can transform into a knowledge-based corporation because the innovation is happening much more faster, worldwide, ubiquitous. A lot of interesting things are happening. There could be integration from the adjacent innovations into your core business. So perhaps that's something you might be interested in. I just want to say, for you to promote innovation, sometimes a light touch is very helpful. Because the question is, how do you finance research? Sometimes research questions, the outcomes cannot be determined so easily. So obviously you need a lighter touch. Same with the startups. Most of the time, startups, they do not know the future, but they have a vision. It's different from large companies or normal businesses. So it requires a different way of handling them, providing them opportunity to succeed. So that's what we call a light touch approach. And just for the scientists out there, even a guy like Newton, he said, I could see far because I am standing on the shoulders of the giants. So it means it's okay to learn from others, other fields, adjacent inventors. And here is an example, Newton, how his interactions in his time. He was interacting with lots of people. I'm sure his innovations has absorbed a lot of things that are going on in other fields, but he able to innovate in his own domain, what he liked to, or what he's passionate about. So in conclusion, innovation is exciting. It's like climbing a mountain. It's tough, but I think it's worth it. With that, I just want to say thank you very much for the opportunity. Thank you.
Thank you very much for your precious contribution to innovation worldwide and here in Morocco today. May I invite you to sit with me over there and maybe we're going to open a question and answer session. Alors, il y a des micros à votre disposition. You have microphones with the hostesses. So please, if you want to think about any question or observation you could make, and you have there your microphone.
Since that gentleman has already asked and
There was
I
a question
promised
there.
that I would answer you, I would take it on. So I would rephrase your question because a large audience, they may not have captured your question. So I will restate it and let me know I got your question properly. What you said is, how do you finance research and how do you raise money? It's tough. Yes? Yeah, so I do agree with that. Research, financing, finding resources is quite challenging. But at the same time, if you ask the question 30, 40 years ago, actually the situation has improved much better globally. I'm not specific to specific countries, but what I have seen internationally, absolutely, there's a lot more support for scientific research and innovation now than, say, 30, 40 years ago. At that time, very limited centers of research, very few people involved. So there's a lot more broader research activity going on globally. There is a support. While the support is there, there's a lot more players and there's a lot of competition. That's one issue. The second one is sometimes people ask, are you actually delivering? How can you provide a solution for a particular problem? And sometimes it's tough to answer as a research scientist, so that's a problem. So here are certain options. One is you continue to better at improving your argument. The second one, you need to get close to the funding organizations like the OCPs as well as other organizations. They need to understand you more than what you expect them to understand you. So there's a lot more time you need to spend. And then there is a regional opportunities I have seen. There are lots of funding opportunities in Africa. Then I've seen South-South relations. There was North-South relation. There are global foundations. So the question is, how do you fine-tune your research, realign it, adjust it? Yeah, that's probably the difficult part. There's another way which we did in the beginning is we encouraged our colleagues, our students, to have as many international partnerships as possible so that you can leverage on infrastructure, facilities, resources that are out there. You do your part, others will do. Along the way, you gain a better traction for yourself, and then probably you're more visible, more trustable in terms of the research money. And then the journey is fascinating and interesting. At least that's what I have seen, yeah.
Thank you very much. Thank you. Financing, for sure. Questions? Mademoiselle, si vous voulez bien remettre le micro. And there is one here. Does a country have to have an innovation strategy? And how to go about it? Because, of course, you're saying there is a direct link between money spent in innovation and development. So how do you plan for this?
Right. So I do not have enough details about your country, so I would not want to comment without the detail. But I can give you the global picture because I was involved deeply in science and technology policy for Singapore. That was done 12 to 15 years ago. At the time, we looked at OECD spending, the world spending, and that roughly you could aim somewhere 2% of GDP to 3% of GDP on research and innovation. And the high-end countries like Norway, Sweden, South Korea, they are spending as high as 5% of GDP on research and innovation. So this is at the broad level as a country. And then the next strategy is, in the past, I would not want to name the countries, but it's an old school of thinking where you have research isolated from the universities, and they found less success compared to the countries where they promoted a seamless working relation between research embedded within the universities, and the industries are working with them. So that is the strategy globally most countries are following. Why would you want to do that is because universities are the place where you have new brains, young minds, and they're more creative, more useful, more interesting. So I think senior people can mentor them. They can share their experience. At the same time, young people can be much more creative. So this is another strategy one could look at, and I think you would not go wrong by engaging that process because you're actually motivating next generation for leaders in a scientific way.
Thank you. Thank you.
I'm GM Patel from India. Sir, I was thinking that when you are telling the 80 gigawatt solar panel in the floating, do you feel any effect on the aquatic life beneath it?
Effect on, sorry?
Aquatic life will be affected by that.
Okay, thank you. So the question is, do we have a concern about the solar farms floating in the ocean? Would it have an effect on the aquatic system, as well as we have a lot of nice coral reefs in Singapore? Answer is, we would have to factor those things carefully. We would have to make sure there is no negative impact on the ocean which we touch, because it's very important, yeah.
In India, in Baroda, the Narmada Canal channel, they have made a solar power system on the channel to see that water doesn't evaporate. But what we have seen, myself also I have seen because I am staying in Baroda, the aquatic life has been affected by that. That's why I'm asking you.
Sure. But I think aquatic life, well, this is true, but in our Singapore case, we have seen suddenly massive algae boom. Recently there was big climatic changes and the way the waterways are happening. So while solar farm has own effect, our understanding of ocean is much more complex. So we would have to factor there are other things that are going on in the ocean. For example, Singapore actually stores oil and gas for the world in our sea. So what we have is the water curtains deep in the rocks, and we actually store emergency oil and gas for the other countries. And this is going on massive. It's massive investments, and the technology is very advanced. So the question is, again, that would have an impact on the aquatic system too. So when we look at it, we would look at all this together, because one is solar, but we also have other things going on there. We're shifting the port itself. In fact, we had a port when you visited 20 years ago, it was in a different location. Now the whole port is being moved. And next year and a year later, it'll completely move to a different location. So we have multifactorial things we would consider. We are very serious about it because Aquatic systems, ecological impact are very serious concern for us. We will definitely do what is needed. There may not be one particular innovation, in my opinion. There would be a multitude of innovation need to be integrated to solve the problems. Yeah.
Professor, we will take probably 2 more questions.
Yeah.
Yes, sir.
Yes.
Alors, monsieur, yes, please. Le micro, s'il vous plaît, Régie.
Yes, please. Amer Recep from OCP. You speak about a large application of innovation in your very interesting conference, and you link it usually to R&D and budget and financing, and especially for university and technology. Do you think that this kind of view, it's not, for me, sufficient, because innovation should be for education also. In young and primary school for kids, if you develop the emotional intelligence for kids during all their education, you will be more sure that your innovation and the development of your country should be good. You don't need usually money, R&D, to have the culture of innovation. I don't know, what do you think about that?
Well, first of all, thank you for keenly listening to my talk. You summarize it very nicely. That's very good. So you're right. It's not just only money. It's about culture. And it's very challenging to change the culture. It's a difficult thing for us. And we find it very difficult to change the culture. Even though we're totally internationalized, for example, at the National University of Singapore, with 38,000 students, can you imagine 80% of these students go abroad? 80%. They go for international stints and exchange. So they are exposed to a lot of international things. Still, the cultural change you identified is much more difficult. Even at the primary schools to secondary schools, we do very well in terms of maths and science. In fact, on OECD ranking, Singapore is #1 for maths and physics and science. That's okay, no problem. The most question is, fundamentally, are you changing the attitude and mindset of the future generations? A lot need to be done. In fact, before this conference started, he introduced himself to me, what he's doing, and I said that's exactly necessary. He is set up himself to promote that entrepreneurial, risk-taking, innovative thinking among the students, younger generation. I have an evidence. As I was running my college as well as other institutions, in the past, in Singapore, if I ask 1,000 students, most likely one would say, I want to do things on my own in the past. But now it has reduced to 1 in 100. I think it's good already. So, of course, we cannot be Silicon Valley. We can't be other, different culture, because culture is a part of a lot of things that goes in the society. It's not so easy to change. While we also feel we make sure that next generation understands and then do things which would make the country better. Well, it's a tough one, yeah.
Hi. Firstly, I would like to say thank you for, right here. Firstly, I would like to say thank you for, let me stand up. Say thank you for your presentation and your initiatives.
Yeah.
My question is related to the whole smart aspect. Is that a lot of things that you talk about innovation, which we all agree here. I believe that innovation is the way forward. But when it comes to smart, everything that's smart means that it will open doors to some risks. Privacy, How can companies that are looking for being connected companies and connected cities in global keep their competitive advantages when everything is connected? These are all points that we need to think about. I think that innovation is great in all of the aspects and all of the businesses, and not just in building smart companies and smart cities, but these risks and points we need to take into consideration, I believe. Thank you.
Thank you for the comment. And yeah, you're right. Every innovation, every change in the industry also comes with other aspects we have to pay serious attention. Cybersecurity, information security, also protecting the data is massively important. I give an example. GE, General Electric, is developing a Predix software, and Siemens has a MindSphere. And it's an open way they design the system, but at the same time, it's not completely open. That's my understanding. So, well, the industries, people that are getting involved, they have to be mindful of the downside, and they would have to work on it. I believe we have to be on the innovation path and see what are the problems we need to be addressed and address them while we make progress in the path of innovation. Because innovation, new scientific advancement of knowledge is what made the human world progressive in the last, my understanding, is 50,000 years. So I think it's part and parcel of humanity. Two things: we advance knowledge, we always innovate. This is, I think, very fundamental for every one of us. So in the process, there would be some downsides. We need to solve them, yeah.
Thank you very much. I would like to thank you for your contributions, and in your name, thank our professor here that gave us this very inspiring discourse. I would like to thank also Mr. Governor for being with us, and the Managing Director of OCP for the opening session. Thank you for being with us. And I would like to invite you now for the inauguration of the exhibition side. There is over 100 exhibitors, and also the poster side, which is very rich. So we're all invited. Then we'll join for lunch and meet again here around 1:15 to listen to Professor Bruce Rittman on using biotechnology to make phosphate more sustainable. Thank you very much. Thank you.
I'm currently pursuing my Executive MBA at Africa Business School of Mohammed VI Polytechnic University, which focuses on some of the pressing challenges facing the African continent. This program, which is truly transformative, is designed to prepare the next generation of African leaders who are culturally aware and socially driven.
J'ai la chance de participer à l'exécutif MBA de l'Université Mohammed VI Polytechnique et surtout la chance d'avoir accès à une formation de qualité internationale fournie par des professeurs reconnus mondialement. L'objectif de l'Africa Business School est de former les futurs leaders africains. Car en fin de compte, l'Afrique n'est pas seulement une source des ressources naturelles ou de la main-d'œuvre à bas prix, mais surtout, demain, le contributeur à l'excellence académique, scientifique et business au niveau mondial.
En donnant en 2012 le coup d'envoi de la construction de l'université Mohammed VI Polytechnique, Sa Majesté le Roi, que Dieu le glorifie, lançait un modèle innovant et intégré de complexes universitaires. Située dans la commune de Ben Guerir, au cœur de la ville verte Mohammed VI, l'université s'inscrit dans un projet d'espace urbain qui privilégie la qualité de vie et le dynamisme économique. Elle s'appuie sur les infrastructures de la ville verte et rayonne autour d'un écosystème de pôles d'excellence créateurs de synergie. Fondée pour la recherche et le développement, l'université propose un agenda qui répond aux défis économiques et sociaux du Maroc et du continent tout entier. Elle offre un environnement exceptionnel qui favorise l'expérimentation et les formations de pointe et ambitionne d'attirer les étudiants les plus brillants. L'objectif, devenir une université de classe mondiale au service de l'Afrique. En contribuant à la formation des futurs leaders du continent, l'université mobilise des chercheurs de haut niveau, parmi lesquels des membres de la diaspora marocaine qui ont fait leurs preuves à l'étranger.
Je suis très heureux d'être venu dans mon pays natal après des années d'expérience et je suis fier de participer à ce projet structurant pour notre pays qu'est l'université qui porte le nom de Sa Majesté le Roi Mohammed VI. Je veux mettre à la disposition de cette institution mes expériences passées dans le domaine des biotechnologies.
After 27 years abroad, I decided to join University Mohammed VI Polytechnic as a professor. I'm especially honored by the opportunity to serve my country and to contribute to establishing innovative and application-oriented research and a startup culture. So our first planned startup will be in the field of nanoengineering. The goal is to serve OCP and other industrial needs in corrosion protection and surface treatment.
Les défis sont nombreux. Sécurité alimentaire, développement économique, industrialisation durable. L'université adopte une approche qui stimule l'expérimentation, l'interdisciplinarité et l'esprit d'entreprise. Avec un objectif, valoriser les résultats de la recherche-développement en fonction des besoins de chaque territoire. Dans une démarche de développement de partenariat, l'université a déployé des programmes de recherche avec des universités et instituts spécialisés au Maroc et dans le monde. Des programmes qui devraient contribuer à transformer le Maroc en un pays à l'avant-garde de l'innovation et participer à la diffusion du savoir en Afrique.
We would like actually to concentrate on digital soil fertility mapping and addressing key soil health and fertility issues in target countries where OCP is working.
Les Living Labs, sites d'expérimentation de l'université, sont la pierre angulaire de ces programmes. Ouverts à la communauté scientifique, ils permettent aux chercheurs des universités de tester des solutions à l'échelle réelle dans des domaines clés. La ville verte propose un modèle urbanistique à forte valeur ajoutée écologique, avec une gestion optimisée des effluents. Le Green Energy Park accompagne le Maroc dans la mise en œuvre de son plan national de développement des énergies renouvelables. La Advanced Technology Mining Platform offre la possibilité de tester de nouvelles techniques d'extraction et de valorisation du minerai. Le Chemical Hub de Safi est un lieu d'expérimentation pour la fabrication des engrais de demain. À travers ces Living Labs, c'est tout le fondement de la formation et de la recherche appliquée qui s'exprime, learning by doing. Ce contexte favorable à l'entrepreneuriat encourage la prise de risque avec des projets de start-up en développement.
Les activités de e-tech tournent autour de la création ou bien le développement des projets technologiques dans des domaines variés comme l'aéronautique, les technologies de l'information, la robotique et essentiellement les énergies renouvelables.
Ancrée au Maroc, l'université Mohammed VI Polytechnique vise à créer un véritable écosystème du savoir à travers l'animation de réseaux dynamiques de recherche. L'université se donne les moyens et le temps de former ses enseignants-chercheurs à travers des projets de recherche et développement, des accords académiques et des conventions avec des institutions de renommée mondiale. Cette ouverture crée un effet d'entraînement et contribue à renforcer les capacités de la recherche et de la formation en Afrique. L'université construit des liens solides avec le monde académique du continent.
I'm currently pursuing my executive MBA at Africa Business School of Mohammed VI Polytechnic University, which focuses on some of the pressing challenges facing the African continent. This program, which is truly transformative, is designed to prepare the next generation of African leaders who are culturally aware and socially driven.
Ouverte sur le monde, l'université l'est aussi à travers sa vocation digitale. Elle développe des modes d'éducation innovants à travers des contenus d'apprentissage numérique et des cours en ligne ouverts. Elle permet la même expérience d'apprentissage par les étudiants où qu'ils se trouvent, Rabat, Casablanca ou encore Laayoune. Institution citoyenne et responsable, l'université veille au partage du savoir au profit des communautés, en adoptant une politique de recrutement socialement inclusive fondée sur le mérite.
Comme un grand nombre de mes camarades, nous bénéficions de bourses, c'est-à-dire que notre université est basée sur un modèle social très juste qui bénéficie à une grande majorité des étudiants et qui nous permet de vivre dans un campus très agréable.
C'est une formation dans l'ensemble très diversifiée qui permettrait donc à chaque ingénieur-manager, futur ingénieur-manager de se retrouver mais aussi de s'épanouir dans un environnement qui offre de belles conditions de vie universitaire, que ce soit au niveau du logement, restauration ou encore le centre sportif de haut niveau.
Premier projet marocain mené sous la certification internationale LEED, qui atteste de son excellence environnementale. Le campus de l'université offre des infrastructures, des équipements et des espaces de vie favorables à l'épanouissement de tous ses membres. Cité du savoir, de la recherche et de l'innovation, l'université Mohammed VI Polytechnique est fière de traduire la vision de Sa Majesté le Roi en faveur du développement durable du Royaume du Maroc et du continent africain. En donnant en 2012 le coup d'envoi de la construction de l'université Mohammed VI Polytechnique, Sa Majesté le Roi, que Dieu le glorifie, lançait un modèle innovant et intégré de complexes universitaires. Située dans la commune de Ben Guerir, au cœur de la ville verte Mohammed VI, l'université s'inscrit dans un projet d'espace urbain qui privilégie la qualité de vie et le dynamisme économique. Elle s'appuie sur les infrastructures de la ville verte et rayonne autour d'un écosystème de pôles d'excellence créateurs de synergie. Fondée pour la recherche et le développement, l'université propose un agenda qui répond aux défis économiques et sociaux du Maroc et du continent tout entier. Elle offre un environnement exceptionnel qui favorise l'expérimentation et les formations de pointe et ambitionne d'attirer les étudiants les plus brillants. L'objectif, devenir une université de classe mondiale au service de l'Afrique. En contribuant à la formation des futurs leaders du continent, l'université mobilise des chercheurs de haut niveau, parmi lesquels des membres de la diaspora marocaine qui ont fait leurs preuves à l'étranger.
Je suis très heureux d'être venu dans mon pays natal après des années d'expérience et je suis fier de participer à ce projet structurant pour notre pays qu'est l'université qui porte le nom de Sa Majesté le Roi Mohammed VI. Je veux mettre à la disposition de cette institution mes expériences passées dans le domaine des biotechnologies.
After 27 years abroad, I decided to join University Mohammed VI Polytechnic as a professor. I'm especially honored by the opportunity to serve my country and to contribute to establishing innovative and application-oriented research and a startup culture. So our first planned startup will be in the field of nanoengineering. The goal is to serve OCP and other industrial needs in corrosion protection and surface treatment.
Les défis sont nombreux. Sécurité alimentaire, développement économique.
I'm currently pursuing my executive MBA at Africa Business School of Mohammed VI Polytechnic University, which focuses on some of the pressing challenges facing the African continent. This program, which is truly transformative, is designed to prepare the next generation of African leaders who are culturally aware and socially driven.
J'ai la chance de participer à l'exécutif MBA de l'Université Mohammed VI Polytechnique et surtout la chance d'avoir accès à une formation de qualité internationale fournie par des professeurs reconnus mondialement. L'objectif de l'Africa Business School est de former les futurs leaders africains. Car en fin de compte, l'Afrique n'est pas seulement une source des ressources naturelles ou de la main-d'œuvre à bas prix, mais surtout, demain, le contributeur à l'excellence académique, scientifique et business au niveau mondial.
I'm currently pursuing my Executive MBA at Africa Business School of Mohammed VI Polytechnic University, which focuses on some of the pressing challenges facing the African continent. This program, which is truly transformative, is designed to prepare the next generation of African leaders who are culturally aware and socially driven.
donnant en 2012 le coup d'envoi de la construction de l'université Mohammed VI Polytechnique, Sa Majesté le Roi, que Dieu le glorifie, lançait un modèle innovant et intégré de complexes universitaires. Située dans la commune de Ben Guerir, au cœur de la ville verte Mohammed VI, l'université s'inscrit dans un projet d'espace urbain qui privilégie la qualité de vie et le dynamisme économique. Elle s'appuie sur les infrastructures de la ville verte et rayonne autour d'un écosystème de pôles d'excellence créateurs de synergie. Fondée pour la recherche et le développement, l'université propose un agenda qui répond aux défis économiques et sociaux du Maroc et du continent tout entier. Elle offre un environnement exceptionnel qui favorise l'expérimentation et les formations de pointe et ambitionne d'attirer les étudiants les plus brillants. L'objectif, devenir une université de classe mondiale au service de l'Afrique. En contribuant à la formation des futurs leaders du continent, l'université mobilise des chercheurs de haut niveau, parmi lesquels des membres de la diaspora marocaine qui ont fait leurs preuves à l'étranger.
Je suis très heureux d'être venu dans mon pays natal après des années d'expérience et je suis fier de participer à ce projet structurant pour notre pays qu'est l'université qui porte le nom de Sa Majesté le Roi Mohammed VI. Je veux mettre à la disposition de cette institution mes expériences passées dans le domaine des biotechnologies.
After 27 years abroad, I decided to join University Mohammed VI Polytechnic as a professor. I'm especially honored by the opportunity to serve my country and to contribute to establishing innovative and application-oriented research and a startup culture. So our first planned startup will be in the field of nanoengineering. The goal is to serve OCP and other industrial needs in corrosion protection and surface treatment.
Les défis sont nombreux. Sécurité alimentaire, développement économique, industrialisation durable. L'université adopte une approche qui stimule l'expérimentation, l'interdisciplinarité et l'esprit d'entreprise. Avec un objectif, valoriser les résultats de la recherche-développement en fonction des besoins de chaque territoire. Dans une démarche de développement de partenariat, l'université a déployé des programmes de recherche avec des universités et instituts spécialisés au Maroc et dans le monde. Des programmes qui devraient contribuer à transformer le Maroc en un pays à l'avant-garde de l'innovation et participer à la diffusion du savoir en Afrique.
We would like actually to concentrate on digital soil fertility mapping and addressing key soil health and fertility issues in target countries where OCP is working.
Les Living Labs, sites d'expérimentation de l'université, sont la pierre angulaire de ces programmes. Ouverts à la communauté scientifique, ils permettent aux chercheurs des universités de tester des solutions à l'échelle réelle dans des domaines clés. La ville verte propose un modèle urbanistique à forte valeur ajoutée écologique, avec une gestion optimisée des effluents. Le Green Energy Park accompagne le Maroc dans la mise en œuvre de son plan national de développement des énergies renouvelables. La Advanced Technology Mining Platform offre la possibilité de tester de nouvelles techniques d'extraction et de valorisation du minerai. Le Chemical Hub de Safi est un lieu d'expérimentation pour la fabrication des engrais de demain. À travers ces Living Labs, c'est tout le fondement de la formation et de la recherche appliquée qui s'exprime, learning by doing. Ce contexte favorable à l'entrepreneuriat encourage la prise de risque avec des projets de start-up en développement.
Les activités de e-tech tournent autour de la création ou bien le développement des projets technologiques dans des domaines variés comme l'aéronautique, les technologies de l'information, la robotique et essentiellement les énergies renouvelables.
Ancrée au Maroc, l'université Mohammed VI Polytechnique vise à créer un véritable écosystème du savoir à travers l'animation de réseaux dynamiques de recherche. L'université se donne les moyens et le temps de former ses enseignants-chercheurs à travers des projets de recherche et développement, des accords académiques et des conventions avec des institutions de renommée mondiale. Cette ouverture crée un effet d'entraînement et contribue à renforcer les capacités de la recherche et de la formation en Afrique. L'université construit des liens solides avec le monde académique du continent.
I'm currently pursuing my executive MBA at Africa Business School of Mohammed VI Polytechnic University, which focuses on some of the pressing challenges facing the African continent. This program, which is truly transformative, is designed to prepare the next generation of African leaders who are culturally aware and socially driven.
Ouverte sur le monde, l'université l'est aussi à travers sa vocation digitale. Elle développe des modes d'éducation innovants à travers des contenus d'apprentissage numérique et des cours en ligne ouverts. Elle permet la même expérience d'apprentissage par les étudiants où qu'ils se trouvent, Rabat, Casablanca ou encore Laayoune. Institution citoyenne et responsable, l'université veille au partage du savoir au profit des communautés, en adoptant une politique de recrutement socialement inclusive fondée sur le mérite.
Comme un grand nombre de mes camarades, nous bénéficions de bourses, c'est-à-dire que notre université est basée sur un modèle social très juste qui bénéficie à une grande majorité des étudiants et qui nous permet de vivre dans un campus très agréable.
C'est une formation dans l'ensemble très diversifiée qui permettrait donc à chaque futur ingénieur manager de se retrouver mais aussi de s'épanouir dans un environnement qui offre de belles conditions de vie universitaire, que ce soit au niveau du logement, restauration ou encore le centre sportif de haut niveau.
Premier projet marocain mené sous la certification internationale LEED, qui atteste de son excellence environnementale. Le campus de l'université offre des infrastructures, des équipements et des espaces de vie favorables à l'épanouissement de tous ses membres. Cité du savoir, de la recherche et de l'innovation, l'université Mohammed VI Polytechnique est fière de traduire la vision de Sa Majesté le Roi en faveur du développement durable du Royaume du Maroc et du continent africain.
J'ai la chance de participer à l'exécutif MBA de l'Université Mohammed VI Polytechnique et surtout la chance d'avoir accès à une formation.
Hello, Professor Ramakrishna. I'm sorry. Well, we've had a very interesting talk on your behalf, and we saw it live actually on SYMPHOS TV, and we were having our own talk. Thank God it was off camera. Well, I'd just like to hear your impressions about being here in Ben Gurion and discovering this university, and what do you think about this type of event and how it helps actually our industry make a better world?
Well, I think when I first came here, of course, this is my first visit, and the moment I alighted here, I realized, and it really fascinated me, what you are putting bricks to build a future. And I think it's really fascinating. And I believe the rest of the world would need to know more about it. And what I saw so far, you have been systematically putting together a strategy and building on that realization in terms of developing the talent and making them relevant to the future industries of not only this region, but for the whole Morocco. And I also understood that these institutions are also trying to integrate as many people as possible from Africa for the innovation, which I think is a really eye-opener for me. And I learned it today, and I feel very happy, and I'm glad to be part of it.
We're very glad to have you here, and I think you put it best, but yes, we have to adapt ourselves to the future so we can actually make it. And well, we'll let you go. Thank you very much, Professor, and well, we'll see you around these 2 days. Thank you. Hello, we're back, and we're finally here with Mr. Boulif, who's going to answer us a couple of questions. Monsieur Boulif, bonjour.
Bonjour.
C'est un plaisir d'être ici avec vous à Ben Gurion au SYMPHOS dans ce très beau campus. It's a pleasure being here on this beautiful campus. What can you tell us about this event and what it represents for your organization? Qu'est-ce que vous pouvez nous dire de cet événement et ce qu'il représente pour votre institution?
Alors SYMPHOS, tout d'abord, c'est un symposium international sur l'innovation autour de l'industrie des phosphates. C'est l'un des plus importants, les plus grands symposiums au monde aujourd'hui dans ce domaine. Cette 4e édition donc, fait suite à 3 précédentes éditions qui ont permis un petit peu de développer un certain nombre de partenariats dans le domaine scientifique et l'innovation autour du phosphate. Cette année, la nouveauté, c'est qu'on l'organise dans une prestigieuse université, c'est l'université Mohammed VI Polytechnique de Ben Gurion, qui, elle, dans sa mission, entre autres, l'innovation dans le mining. Et donc, cette année, nous sommes dans les 950 000 personnes qui vont discuter sciences, technologie, innovation autour de l'agriculture, autour de l'énergie, autour de la protection de l'environnement, autour de l'industrie de phosphate, des technologies. Nous avons accueilli aussi dans les 105 exposants à travers le monde. Ils viennent des États-Unis, ils viennent de la Chine, ils viennent de Singapour, ils viennent de différents endroits du monde pour promouvoir leurs produits, leur savoir-faire et partager ce savoir avec le monde industriel, le monde scientifique. Comme j'ai dit, nous sommes 43 pays, mais 43 pays dont les scientifiques qui sont là, donc qui des sciences, des technologies, des innovations. Donc ça va permettre, je dirais qu'il y a la crème dans ce domaine aujourd'hui ici. Et alhamdoulilah, on essaye de tirer profit donc, de cette manifestation, monter des partenariats avec les équipes, partager aussi notre savoir-faire à travers le monde. L'objectif, c'est donc, comme j'ai dit, une agriculture durable pour le bien du monde.
D'accord, merci beaucoup. Juste une petite question avant de vous libérer. Ce campus est extrêmement beau. Ça donne vraiment envie d'avoir 19 ans et de recommencer ses études, n'est-ce pas?
Effectivement, moi, je suis à l'OCP, mais je viens souvent ici à l'université pour s'inspirer un petit peu, rester dans le domaine, je dirais, universitaire, discuter avec les professeurs, discuter avec les étudiants. Et c'est ça qui donne envie donc, de continuer à faire de la recherche dans le domaine en général et en particulier dans le domaine des phosphates.
Merci beaucoup, M. Bouli.
Merci et au plaisir.
Excellente journée. Bonne...
donnant en 2012 le coup d'envoi de la construction de l'université Mohammed VI Polytechnique, Sa Majesté le Roi, que Dieu le glorifie, lançait un modèle innovant et intégré de complexes universitaires. Située dans la commune de Ben Guerir, au cœur de la ville verte Mohammed VI, l'université s'inscrit dans un projet d'espace urbain qui privilégie la qualité de vie et le dynamisme économique. Elle s'appuie sur les infrastructures de la ville verte et rayonne autour d'un écosystème de pôles d'excellence créateurs de synergie. Fondée pour la recherche et le développement, l'université propose un agenda qui répond aux défis économiques et sociaux du Maroc et du continent tout entier. Elle offre un environnement exceptionnel qui favorise l'expérimentation et les formations de pointe et ambitionne d'attirer les étudiants les plus brillants. L'objectif, devenir une université de classe mondiale au service de l'Afrique. En contribuant à la formation des futurs leaders du continent, l'université mobilise des chercheurs de haut niveau, parmi lesquels des membres de la diaspora marocaine qui ont fait leurs preuves à l'étranger.
Je suis très heureux d'être venu dans mon pays natal après des années d'expérience et je suis fier de participer à ce projet structurant pour notre pays qu'est l'université qui porte le nom de Sa Majesté le Roi Mohammed VI. Je veux mettre à la disposition de cette institution mes expériences passées dans le domaine des biotechnologies.
After 27 years abroad, I decided to join University Mohammed VI Polytechnic as a professor. I'm especially honored by the opportunity to serve my country and to contribute to establishing innovative and application-oriented research and a startup culture. So our first planned startup will be in the field of nanoengineering. The goal is to serve OCP and other industrial needs in corrosion protection and surface treatment.
Les défis sont nombreux. Sécurité alimentaire, développement économique, industrialisation durable. L'université adopte une approche qui stimule l'expérimentation, l'interdisciplinarité et l'esprit d'entreprise. Avec un objectif, valoriser les résultats de la recherche-développement en fonction des besoins de chaque territoire. Dans une démarche de développement de partenariat, l'université a déployé des programmes de recherche avec des universités et instituts spécialisés au Maroc et dans le monde. Des programmes qui devraient contribuer à transformer le Maroc en un pays à l'avant-garde de l'innovation et participer à la diffusion du savoir en Afrique.
We would like actually to concentrate on digital soil fertility mapping and addressing key soil health and fertility issues in target countries where OCP is working.
Les Living Labs, sites d'expérimentation de l'université, sont la pierre angulaire de ces programmes. Ouverts à la communauté scientifique, ils permettent aux chercheurs des universités de tester des solutions à l'échelle réelle dans des domaines clés. La ville verte propose un modèle urbanistique à forte valeur ajoutée écologique, avec une gestion optimisée des effluents. Le Green Energy Park accompagne le Maroc dans la mise en œuvre de son plan national de développement des énergies renouvelables. La Advanced Technology Mining Platform offre la possibilité de tester de nouvelles techniques d'extraction et de valorisation du minerai. Le Chemical Hub de Safi est un lieu d'expérimentation pour la fabrication des engrais de demain. À travers ces Living Labs, c'est tout le fondement de la formation et de la recherche appliquée qui s'exprime, learning by doing. Ce contexte favorable à l'entrepreneuriat encourage la prise de risque avec des projets de start-up en développement.
Les activités de e-tech tournent autour de la création ou bien le développement des projets technologiques dans des domaines variés comme l'aéronautique, les technologies de l'information, la robotique et essentiellement les énergies renouvelables.
Ancrée au Maroc, l'université Mohammed VI Polytechnique vise à créer un véritable écosystème du savoir à travers l'animation de réseaux dynamiques de recherche. L'université se donne les moyens et le temps de former ses enseignants-chercheurs à travers des projets de recherche et développement, des accords académiques et des conventions avec des institutions de renommée mondiale. Cette ouverture crée un effet d'entraînement et contribue à renforcer les capacités de la recherche et de la formation en Afrique. L'université construit des liens solides avec le monde académique du continent.
I'm currently pursuing my executive MBA at Africa Business School of Mohammed VI Polytechnic University, which focuses on some of the pressing challenges facing the African continent. This program, which is truly transformative, is designed to prepare the next generation of African leaders who are culturally aware and socially driven.
Ouverte sur le monde, l'université l'est aussi à travers sa vocation digitale. Elle développe des modes d'éducation innovants à travers des contenus d'apprentissage numérique et des cours en ligne ouverts. Elle permet la même expérience d'apprentissage par les étudiants où qu'ils se trouvent, Rabat, Casablanca ou encore Laayoune. Institution citoyenne et responsable, l'université veille au partage du savoir au profit des communautés, en adoptant une politique de recrutement socialement inclusive fondée sur le mérite.
Comme un grand nombre de mes camarades, nous bénéficions de bourses, c'est-à-dire que notre université est basée sur un modèle social très juste qui bénéficie à une grande majorité des étudiants et qui nous permet de vivre dans un campus très agréable.
C'est une formation dans l'ensemble très diversifiée qui permettrait donc à chaque ingénieur manager, futur ingénieur manager, de se retrouver, mais aussi de s'épanouir dans un environnement qui offre de belles conditions de vie universitaire, que ce soit au niveau du logement, restauration ou encore le centre sportif de haut niveau.
Premier projet marocain mené sous la certification internationale LEED, qui atteste de son excellence environnementale. Le campus de l'université offre des infrastructures, des équipements et des espaces de vie favorables à l'épanouissement de tous ses membres. Cité du savoir, de la recherche et de l'innovation, l'université Mohammed VI Polytechnique est fière de traduire la vision de Sa Majesté le Roi en faveur du développement durable du Royaume du Maroc et du continent africain.
And there are my slides. Wonderful. Well, first of all, I'd like to thank the organizers of SYMPHOS, as well as OCP and the University Mohammed VI Polytechnic, for having me here today. I've spent about a week now in Morocco, and I've learned a lot about phosphate mining and making fertilizers. And I've also enjoyed getting to appreciate the culture, the cuisine, and the history of Morocco. It's quite wonderful. Okay, so now let's turn to the concept of sustainable phosphate fertilizer. So here's the definition that I used for this, for sustainable phosphorus. What happened? Oh, hi. But my slides, okay. What do I do? But it's not up. Well, at this point, they always say you should tell jokes. Unfortunately, I'm not prepared for telling jokes, so I won't. But I will say that when I was asked to give this talk, I was very happy to accept, and it provides a new opportunity for me to think about environmental biotechnology in a new setting, and this is the setting of fertilizers and soil fertility. In environmental biotechnology, we're understanding and managing microbial communities to provide services, and for me, this will be a new service. And let's see if we can get the slides to do it here. Laser pointer works. That's good. It's coming. Okay, he says the slides are coming back. All right. Okay. All right. We'll start again here. So the topic is a more sustainable phosphate fertilizer. And so I'm going to begin with my definition of this. It is up there. Wonderful. So as you can see, the definition I'm using is sustainable phosphorus means optimizing P use so that abundant, nutritious food coexists with healthy aquatic ecosystems. Now, I'm going to come back to this definition in just a couple minutes as I launch into the technical part of my talk. But before I do that, I do want to introduce to you an organization called the Sustainable Phosphorus Alliance, or SPA, S-P-A. This is a relatively recent organization that was founded by Arizona State University to promote sustainable phosphorus. And it's a member-funded, multi-stakeholder organization to help the whole world make its use of phosphorus much more sustainable. Down at the bottom of the slide, you'll see the founding members of this. We have additional members that are not on the slide, but these are the founding members, and I'm very happy to see that OCP is one of them. So what do? We try to help people do a better job of making sustainable phosphorus in the whole process, from mining to use to recovery, all of it on this. For example, we hold annual conferences. We have one coming up next week here in Washington, D.C. I know a few people in the room besides me will be at this Phosphorus Forum 2017 on it. So that's one of our focus events. In addition, we try to do things that help people who are interested in making phosphorus use more sustainable. We have workshops. And also, if you're interested in not only doing more sustainable phosphorus, but being recognized for doing more sustainable phosphorus, then SPA is a very good organization to help with your branding. So that if you're interested in SPA, please contact me either today at the conference or by email later, and I'll get you in contact so you can join us and we can join you. Okay, now back to the definition of sustainable phosphorus and into the technical aspects of my talk. So sustainable phosphorus means optimizing P use so that abundant, nutritious food coexists with healthy aquatic ecosystems. You can see where I put the emphasis at this point. So healthy aquatic ecosystems is the driving force behind why we really need to make phosphorus in all aspects more sustainable. So here is a picture from a very, very famous study done in the 1960s by Dave Schindler. His picture is there. He's a professor at the University of Alberta in Canada, and he did a study in which he divided a lake in Canada into two parts. You can see the dam dividing it. On one side, he added carbon and nitrogen, and the other side, he added carbon, nitrogen, and phosphorus. And you can see one is really green. That's the one where phosphorus is added. So this was just a groundbreaking study documenting the important role of phosphorus in spurring excessive growth of microalgae or eutrophication on this. Now, around the world, at least in the United States and Canada, we did many, many things to remove phosphate from detergents, to treat wastewater, and we thought we really had things pretty well solved for many of our sensitive lakes. However, at the beginning of this decade, things changed. And so here is a photograph, an aerial photograph of Lake Erie, which once again has very, very serious problems of eutrophication, and these are caused by the runoff of phosphorus from agricultural fields. So the problem has become unsolved, and we know why it's unsolved. Now, this isn't just a problem of Lake Erie or a few places around the world. This is a widespread international water quality challenge. And so here's a heat map showing the anoxic zone in the Gulf of Mexico near the outlet of the Mississippi River in the southern United States. But this is only one. There are more than 400 of these hypoxic, almost dead zones around the world. So this is a giant international problem. And it's one that is caused primarily by the runoff of phosphorus from various agricultural activities. Now, a key thing to keep in mind is that we mine a lot of phosphorus. Most of it goes into fertilizer, and most of that phosphorus does not go into our food. So Donna Cordell and her colleagues in Australia did some fabulous work on doing a mass balances on phosphorus globally, and in 2009 they published a landmark paper that I show you here, in which they showed that only about 16% of the mined phosphorus globally ends up in the food. The rest, most of the rest, ends up either in agricultural runoff from the fields or in animal waste. And it's this lost phosphorus, the stuff that never makes it to our field, that's getting into the waters, causing eutrophication, hypoxia, and dead zones. We did a paper in 2011 in which we adapted the work from Cordell and produced this table here, and it just shows you in the red where are the big places where the phosphorus is getting out of the human and agricultural system and into the waterways, causing these problems. And you can see 46% from soil erosion and runoff, 40% from animal waste, and about 8% from human wastewater. So most of it is coming from the food sector directly. Now, I'm going to show this diagram a couple times in my talk today. And on the left-hand side of this diagram, you will see three characteristic sources of phosphorus that get out in the environment. The top one is what we call high phosphorus, high BOD concentration. These are, high refers to the concentration in the stream. And this, the classic example of this would be animal waste. Very high in phosphorus, very high in organic material. The medium one would be things like human domestic wastewater. And then the bottom one is low phosphorus and low BOD concentrations, and this would be characteristic of your agricultural runoff and drainage. Now, I'm going to start off very briefly in talking about the high and medium concentration ones. And this is not the main point of my talk today, but it provides really important context when we look at what are we going to do to make phosphorus more sustainable. So because these have a lot of BOD or organic material, these waste streams also contain a lot of energy. And so we can convert the organic material into valuable energy forms, as I show up at the top right, things like methane or hydrogen, and at that same time releases organic phosphorus into becoming inorganic phosphorus or phosphate that is recoverable. And so this is a really great system here because we get at least two major benefits out of the material, energy and phosphorus. Well, in fact, we get more than that, as I'll show you. But the key thing I want to point out today is there's a very important take-home lesson for these high and medium strength waste streams is that we now today in the middle of the 2010s decade, we now have technologies that allow us to treat these anaerobically to capture the energy value either as methane through methanogenesis, a very long-standing process, but that has been greatly improved in the last few years so that now it works well for all of the waste streams that were in that top group. Or we can use some more emerging technologies in microbial electrochemistry, that's the second bullet there, where we can generate electrical power or hydrogen gas or hydrogen peroxide or some other materials that have higher economic value than does methane. Now these ones in the second category, the second bullet, are not ready for commercial application yet. I mean, these are still emerging research and development technologies, but they have a lot of downstream potential, and our group and many others are working on it. Again, when you convert the organic material into energy, any of these energy forms, you release the phosphorus as inorganic phosphorus, and it can be captured by a range of techniques that are available now. They're all available now. None of them have been fully optimized for this application of recovering phosphorus, but we have the technologies out there that are being readied for this great application. So if you look at the economic question here, economic balance on these, you ask, well, is it worth our effort, our economic effort to do this? And so our team has done some detailed techno-economic analyses of these systems where we take these wastewaters and we capture the energy, we capture the phosphorus, also the nitrogen and the water. And so this diagram here is a bar chart showing the costs and the benefits of doing this. So the left two bars here, the left two bars are using methanogenesis to capture the energy value as methane gas, and the left bar are all the benefits from the energy, the benefits from the recovering the ammonium and the phosphate, as well as recovering the water. The right-hand bar are all the costs, the capital costs and the operating costs. And what you can see is that the operating costs are less than the benefits. So this is actually a moneymaker, and this is for a particular scenario of about 6,500 dairy cows, and this would be making an operation like this about $200,000 per year. If we could develop and commercialize the technologies, the microbial electrochemical technologies to make hydrogen gas, then we move to the right-hand bars, we get a much, much higher economic value out of the energy, and we'll make almost $1 million per year on that. Now, the take-home lessons here on this is that, one, energy is the main economic driver in either setting. The biggest economic value comes from the energy. However, the nutrients are significant. And on the left-hand two bars, it's actually the amount that turns it from being cost neutral to actually cost positive. Okay, so that's all I'm going to say about these high and medium strength ones. What I'm really going to talk most about today is the bottom one, and that is low phosphorus and low BOD, the runoff and drainage. This doesn't have organic material in it. It's not going to generate any energy, and so you can't do that. So we're basically relying on the water and on the nutrients to provide economic value. So again, no energy output. That's a key take-home lesson. You're not going to get the energy value from it. There is none. Now, my conclusion, when I think about this bottom category, is that recovering phosphorus from the runoff is difficult. It's actually relatively easy to recover the phosphorus from the animal waste and even domestic sewage. It's hard to do it from the runoff for three reasons. One, I've already told you, there's no energy. We can't gain an economic benefit from capturing the energy because there is none. Second, it has a relatively low P concentration, so that makes it technically more difficult to capture it. And third, it's often very periodic loading. It's when it rains, and you get a huge loading of phosphorus in a very large flow, and then when it's dry, nothing. So it's very hard to design technologies to capture phosphorus successfully in this very difficult setting. So maybe we should think of another way of doing it. Don't approach it from the treatment point of view, treatment and capture. Let's try a different point of view to making this P from the drainage and the erosion more sustainable. And that is, let's minimize the loss of the P from the fields in the first place. Let's not lose so much from the fields. And so we want to produce a phosphate-containing fertilizer that is more available to the plants, so we can apply a lot less P, so that a lot less P is going to be discharged when there's a rain event. Okay, so this is the general concept of it. I'm sure everybody in this room has seen a chart something like this. It's just showing the availability of phosphate by soil pH. And you can see in the center part here, whoops, I hit the wrong button there. In the center part here, you've got the sweet spot. This is where the phosphate does not precipitate very much and is available to the plants, but at high pH or low pH, you get a lot of precipitates. And the low pH, you get the iron and aluminum phosphates. The high pH, you get the various calcium phosphates. So it makes it unavailable. You apply a lot more phosphorus than the plants need, and a lot of it runs off. Now, it's not so difficult to fix the low pH problem. You can add lime and to raise the pH, and lime is cheap and easy to find, but it's not so simple for the alkaline soils. And that's what I'm going to focus the rest of my talk on, is what might we do using microbiology or environmental biotechnology to try to improve the situation for the alkaline soils, making the phosphorus more available so we can use less and get less runoff. So how can microbiology help? So the general principle, the overarching general principle, is that we want to prevent the precipitation of the phosphorus, which makes it unavailable. We want to make it more available, and then we don't need so much. So I'm going to talk about two possible microbiology approaches to doing this. The first one is to take advantage of microalgae, who have the great ability to rapidly absorb a lot of bioavailable phosphorus. And then I'm also going to talk about fortifying fertilizers with ammonia oxidizing bacteria to produce acid, so we have in situ neutralization of alkaline soils. So let's do both of them. Number one, using microalgae to absorb phosphate. First of all, what are microalgae? These are photosynthetic microorganisms that are constituted by green algae, that's shown here. That's one Cynodesmus, one green algae, and then our cyanobacteria, which is shown in the picture above. So they're photosynthetic. They use sunlight as their source of energy. They use inorganic carbon, we often call it CO2, as their carbon source, and water is their electron donor. So these are all things that are around. The sun's around, CO2's around, water's around. So we don't have to go out and find anything exotic to grow these organisms. Now, what we're going to take advantage of is these microalgae's ability to scavenge phosphorus at very, very low concentrations. They developed this evolutionarily over many millions of years because they need to. These organisms in their normal environment are exposed to really low phosphate concentrations unless we put in a lot of extra phosphate because of eutrophication. So they have to be adapted to be able to grab any little phosphorus molecule that comes by and hold it because it's so precious to them. And it's also why, if you look at the standards for protecting water quality from eutrophication, you see that the concentration goals are really low, something like 0.02 milligrams of P per liter. And so these organisms live in these environments and they're very capable of scavenging very minute concentrations of phosphorus. So how do they do this? Well, they do this by absorbing it or complexing it with amine groups. Amine groups are part of amino acids. Amino acids are part of proteins. So these organisms have proteins on the inside of them, they have proteins on the outside of them. Both of these proteins have amine groups that can complex or bind to phosphate. And that's shown here, simply here. Here's the amine group, there's a phosphate, and they bind to form a complex. And there's a chemical equilibrium representation of it. And they're very good at this. They combine it quite efficiently and rapidly. So how does that work? Well, if you look at this diagram here, what you see here is that we got some inorganic phosphate in a bulk solution. BS stands for bulk solution. That's the water surrounding the organisms. It can rapidly be complex to the extracellular polymeric substances. This is the outside of the cell, or to the internal amine groups here. And so when there's a lot of phosphorus out there, it quickly goes in here or quickly goes here. And then when the organisms need the phosphorus to grow, they simply release it and it comes back and it can go in to spur their growth. So it's naturally bioavailable. So how do we know this is true? So we've been doing a lot of experiments on this topic recently because we're really interested in how phosphorus controls the growth of our microalgae. So here's some results from an experiment in which we exposed some microalgae in the dark, no light, in the dark, so they're not doing photosynthesis. And these were algae that had been grown with different amounts of internal and external phosphorus. And what you can see is the top graph is the uptake, very rapid uptake of phosphate, and this is the buildup of the phosphate complex on the outside and complex on the inside. And particularly if we start with organisms that have low phosphate to start, they can build up a lot very quickly. So within about 2 hours, they've almost saturated their ability. They're taking up a lot of phosphorus. And that amount of phosphorus that they take up is correlated to the protein content, because the protein is where the amine groups are. So this is just correlation here. Whoops, correlation for the extracellular phosphate. Okay, so now the organisms have the phosphorus. They sucked it up really fast, but is it available, and can they use it? And could any organism use it? And the answer is yes. So if you now run that similar kind of experiment, but in the light, it looks like this. So here we have three experiments run in parallel with different amounts of phosphorus. A lot of phosphorus, medium amount, hardly any at all. And the light is on the whole time. So what happens is initially they take up the phosphorus, as you can see here, and they don't really grow much. This is the growth. This is the biomass growing. Not much happens because they're taking up phosphorus. Eventually, they've taken up the phosphorus and the organisms start to grow. Now, the thing to note here is that the growth rate of these organisms is the same, whether we have a lot of phosphorus still in the water or zero. So the phosphorus in the water isn't controlling their growth. It's the phosphorus that they have absorbed by this complexation reaction. That is what controls it. And that's shown in the next graph. If we just look at the left side, this is for the internal phosphorus here. You can see that this is the rapid uptake here, and then after a while, they've taken up enough and they start to grow and you get this depletion. So first it takes it up, and then it depletes it, and these organisms are growing. So this is naturally bioavailable phosphorus. So how might we do this? Well, we could grow our microalgae, and I'm just showing here some facilities for growing them at our university. We would then, when the organisms are depleted of phosphorus, we would then harvest them. We could then mix them with phosphorus as part of the production of the fertilizer, as you can see down here. And we would then have fertilizer with much more sustainable P, because the P would be bound to the microorganisms, the amine groups, not just free P. And this should greatly reduce the amount of precipitation and loss of availability. Okay, second possibility here of applying some environmental biotechnologies in a novel way, and that is to fortify the fertilizer with nitrifying bacteria to lower the alkalinity and pH. So what we want to do is we want to create a system where the organisms and the conditions that these organisms like are commensurate with what goes on in fertilized soil. And so we need the bacteria and the soil and the plants, all this to be working together and be, have a complementary setting. So nitrifying bacteria use ammonium and they produce nitrate. These ammonium and nitrate, of course, are well-known nitrogen fertilizer components, so that's good. 2, the bacteria are aerobic, the soil is aerobic, so you've got oxygen, it works fine. So far, everything is good. The things the organisms need are compatible with the way the soil system works. So what about these nitrifying bacteria? Who are they? So they come in 2 groups. First is the ammonia oxidizing bacteria, or AOB, and they take ammonia and they oxidize it using oxygen to produce nitrite. So there's ammonium using oxygen, forming nitrite, and forming acid. So they form a lot of acid. There are lots of known species. I just listed 2 common names here. They're obligate aerobes. They must have oxygen. Then the nitrite can be further oxidized using more oxygen to nitrate. And again, there are many strains that use this, and I've listed a couple here. They're also aerobic. Now, when I looked at this, I said, well, I'm interested in producing acid to neutralize some of the base in the alkaline soils. It's only the first step that produces the acid. So maybe I only want the first step and I don't want both steps. I don't know about that, but perhaps if plants are capable of using nitrite instead of nitrate, perhaps we could just use one step out of the 2. It makes it a little simpler that way. Okay, so but whether we use one step or we use both steps of the microbiology, we have a situation where we take and we're moving from the right side more to the center side here of this diagram, making the phosphorus more available in the field. So what about nitrifying bacteria? What about them and the conditions that will stimulate these bacteria so they'll really work well in this setting? So I've listed some key things here. I mean, they are obligate aerobic. They have to have oxygen. Fortunately, soil is very aerobic unless we just put in way too much water. So if we keep it from being waterlogged, we'll have oxygen. So that will stimulate the organisms. 2, these are autotrophic microorganisms. Autotrophic means they use inorganic carbon or CO2 as their carbon source. They do not use organic material. They don't need any added organic material. They will not use the soil's natural organic material. In fact, they will add to the soil's organic material. So that's a good thing. 3, they do grow in water. All microorganisms grow in water, and so you do need to have a reasonable moisture content in the soil. Typically, about 10% of the soil moisture holding capacity will be quite good. Now, the last point here is very important. These nitrifying bacteria are very slow growers. They don't grow fast. And so what this means is that to make this strategy work, we will actually have to add the organisms in with the fertilizer, or at least in the fertilizing process, because they're slow growers. They're not going to grow up in a day or so. So we'll need to add a substantial amount of them. So we'll have to grow them and add them into the mix. And it might look something like this. We grow the microorganisms in a big reactor like this, harvest out the cells, and we add the cells with some ammonium and the other constituents to form a fertilizer that has the intrinsic ability to do this in situ reduction of the alkalinity and pH. Now, before I end, just one last thought. As I was researching all of this, I came across a lot of information on testing of bioavailable phosphorus. I'm sure most of you know a lot more about this than I do on this, but I've learned that there are a lot of methods, and I've listed a lot of the common names. I'm sure most of you recognize these names. So there are a lot of options out here, and the key thing is they don't give the same answer. Even when they're used on soils where they're supposed to be optimized, they don't give the same answer. So this is actually distressing, because how do we know if our sustainable P-available fertilizer with our microorganisms in it is actually giving us more bioavailable P? So maybe we don't have adequate methods to assay this already, and that would mean we would perhaps need to develop some more appropriate methodology to assess the bioavailability of phosphorus in this system where we're attempting to make the P more bioavailable through microbiological means. Okay, I'm coming to the end here, and I'm going to just summarize briefly the main take-home messages of my talk. 1, water quality needs are really important. They dictate the need for us to greatly reduce the amount of phosphorus that is being eroded from agricultural fields. It's the #1 cause of eutrophication worldwide, and we've got serious problems worldwide, more than 400 documented cases. For the agricultural applications, perhaps our best strategy is to make the phosphorus a lot more available so that we do not have to add so much. And it will be taken up rapidly by the plants, and we won't have the huge runoff problems that we do now. How would we do that? I've offered 2 possibilities. They make sense from the microbiology point of view. I'm not an expert in agronomy and soil fertility, so those concepts will have to be merged with anything I say, but from the microbiology point of view, these make sense. One is to bind the phosphate to microalgae who have very strong capabilities to rapidly absorb or complex phosphate that is bioavailable. That's how they live, and we can take advantage of this if we design the system correctly. And the last one is the possibility of actually having an in situ production of acid to reduce the pH and the alkalinity of highly alkaline soils, and therefore making the phosphorus in whatever form we apply it less precipitated and more available. So with that, I'm coming to the end here. I do want to say that if anyone would like to chat with me about any of these things, we have two choices. I will be here for the rest of the day. I have to go home tomorrow, so it's only today. However, at the bottom you can see here's my email address, so if you don't catch me today and you have something you'd like to discuss, please send me an email and I'll be happy to respond to you. So with that, thank you very much, and I look forward to having a few questions. Thank you.
Thank you again, Dr. Rickman, for that excellent presentation and sharing with us how biotechnology can help us to increase phosphorus use efficiency from the microbiological standpoint. So we have time for a few questions, though we are a little behind, so if you could please take your seat. And this session is open for discussion. So we have few people out here, so the first person from the front here.
Thank you for the opportunity. Mine is more of a comment, but I'll push it as a question. I see that what you've presented has really been able to help maybe the developed world, where there've been a lot of investments in fertilizer and use of fertilizers, maybe US, Australia, and other places. While in Africa, it's the opposite of it, that there's very little use of fertilizer. In fact, when we have runoffs, it's more of a maybe sedimentation issue than maybe having a lot of phosphorus in the runoffs because of maybe large management aspects. So out of the options that you've given, I would want to ask, what do you see as the most relevant approach for Africa? Because we cannot start talking about having excess of it or losing it before we are even able to put it in the soil. So how do you bring that to the context of Africa? Thank you.
Well, that's a wonderful question. For context, of course, I developed my talk, my ideas around the developed world agricultural system. I mean, that's what I know about. And so I haven't really pondered what you would do if you really didn't have enough phosphorus anyway. That wasn't what I was looking at. I would say the one thing that I will say, I'm going to go back to the early part of my talk when I was discussing the recovery of phosphorus and energy and other things from the animal wastes and human waste. I mean, so if you have animals and you have humans, you have this resource, and that'll be everywhere. And so I think that one there is actually universal. And what we need to do in the case of Africa is adapt it so that it can be applied in the setting. It's not going to be, a big Western city with already all kinds of infrastructure in place. It'll have to be a different, maybe much more localized, decentralized thing. So, but I think there's a huge amount of promise there for recovering the energy, recovering phosphorus and nitrogen, and recovering the water at the same time, and you need all of them. So that would be my best answer I can give you today on that question.
We have time for maybe another quick question. Tom, please.
Thank you.
Tom.
Yes,
Should I go?
Thank you. Tom Brolsma from the International Plant Nutrition Institute, and thanks for that presentation, Bruce. I think there is some of the very original ideas there. The idea or the concept of enhancing nitrification to make the phosphorus more available this is the first time I've heard of that one. But I wonder if you've thought through whether what we would do with the excess of nitrate. In a lot of North American agricultural management, we're actually trying to retain the ammonium form as long as possible, since nitrate also contributes to these hypoxic zones.
Absolutely. You're completely right. So the key here would be that in implementing this strategy, you wouldn't, acidifying the soil could not be the driving mechanism. You couldn't say, we'll just add as much ammonium as we want to, lower the pH, and who cares if we had, 10 times too much nitrogen. We couldn't do that. That would be completely defeating the purpose of this. So the key is then, a balancing of under what conditions could you get the double benefit. You would get the benefit of the nitrogen fertilizer, and you would get the benefit of the acidification. And when would you get enough acidification into those settings to make it worthwhile? And if you have a really, really strongly alkaline soil, you probably couldn't do it, but maybe it's only mildly alkaline, you might have the right balance. And so those are the kind of questions we would have to look at in terms of moving forward with implementing something like this.
Okay. One last question, please, just to wrap up this session. Yes, please.
Yes, congratulations for the tremendous presentation. I was amazed to see how much phosphate could be diverted from most valuable applications. You have developed this biological approach using microalgae. I was wondering whether you think that engineering phosphate, which means having certain speciation, a certain shaping, a certain conditioning, could reinforce the solubility against the runoff, for example. Is there any way else to just engineer the product in the sense that this may control a little bit the phosphate release?
Yeah, well, I'm far from an expert in phosphate chemistry and how it relates to, the use in plant nutrition. So what we're doing here with the microalgae is we're changing the chemical form of the phosphate. We're complexing it to amine groups. And so you could do this, I'm suggesting you can do it with microalgae because we can easily grow a lot of microalgae. You could imagine other sources of amine groups from other sources, other agricultural materials would do the same thing. And so I think the concept goes beyond microalgae, but in microalgae, we are really changing the chemical form.
Well, with that, I would like to wrap up this session. Thank you, everybody, for attending and for bearing with us. And please join me once again in thanking Dr. Reithman for this presentation. So next on the agenda is the breakout session, and I understand the next session on agriculture is going to take place right in this room. So for other sessions, please find your way to your respective rooms, and I wish you all the best as we progress with this symposium. Thank you very much.
key roles in developing and implementing the 4R University Washing concept as a framework for connecting science to practical management of crop nutrition. Dr. Busuman has been recognized as the Fellow of the American Society of Agronomy, the Soil Science Society of America, and the Canadian Society of Agronomy. Currently, he is developing the Institute's phosphorus program, focusing on phosphorus management for sustainable agriculture. Today, Tom will be speaking on industry initiative enhancing phosphorus sustainability. The floor is yours.
Thank you. Thank you, Babasola, for the introduction and for the opportunity to speak today. I guess before I begin, as we're getting the slides up here, I'll just say I really appreciate the opportunity to be here in Morocco. I was here once before 6 years ago, and really have had only a limited opportunity to explore anything related to Moroccan agriculture. But what I'm speaking today about is industry initiatives enhancing phosphorus sustainability, in a sense continuing on from Bruce Whitman's presentation this morning, where I learned there are many dimensions and many ways of looking at the phosphorus sustainability issue. Joining in with me in this presentation is Shami Zingor, my IP&I colleague who is based in Nairobi, Kenya, and covers sub-Saharan Africa. And essentially what I'll be doing is looking at two initiatives, one from the area where I work and the other where Dr. Zingor works. The International Plant Nutrition Institute is a member-supported organization. Our members are the producers, primary producers of fertilizer nutrients, nitrogen, phosphorus, potassium, and sulfur. And we've been around since 2007, almost 10 years old. Essentially, what I'll be doing is giving a very brief overview of phosphorus sustainability issues, and then looking at two specific examples where we've implemented what we call the crop nutrition industry's sustainability program in different ways. Our sustainability program is called 4R Nutrient Stewardship, applying the right rate, right at the right time, and in the right place of the right source of fertilizer. So there's 4 R's to remember there. And what defines right, essentially, is what makes the cropping system more sustainable environmentally, socially, and economically. And what I'll be demonstrating to you in essence is that this program applies equally well to these very disparate situations, despite the differences in soils, in climate, and in cropping systems, and also the differences in regional priorities for sustainability. In Lake Erie, I'll talk about 4R practices and a 4R program that's been introduced. Likewise, in Africa, I'll be talking about practices, and then a specific project that was implemented in Kenya with a fair amount of success. Copies of these slides are available at the URL indicated below, phosphorus.ipni.net. So if I'm running too fast over the details, you can pick them up on the web. So, the phosphorus sustainability initiatives, I've been introduced to this for just the last 2 years in the position of phosphorus program director. I've seen many publications, many organizations have been created in the last 5 to 10 years or so that address specifically the sustainability of phosphorus. And what I've boiled it down to is, I guess, 3 main sustainability concerns that are mentioned fairly often. Number one is the one that seems to have driven the issue and interest is the whole idea of phosphorus being a finite resource. They're interested in the resource being consumed, and therefore we need to increase the use efficiency of the whole system. And that certainly is a concern. The industry does share. Relative priority may differ depending on who you're talking to. The other issue is there are trace elements in phosphate rocks, and there are trace elements in recycled sources as well. And that the loading to soils and keeping agricultural soils healthy and suitable for growing crops is a big concern. And then finally, last but certainly not least, and in fact the one that most of us in the industry see the most need to work on is the water quality impacts. And I think Bruce emphasized that this morning and this afternoon as well. So these are the organizations. This is driving a lot of interest and spreading the interest in phosphorus beyond the traditional agronomic circles in which our institute used to operate. I've been introduced to people who deal with things that I've never thought about before, when we deal with the sociological impacts and the tracing phosphorus in its use through society. So, I mentioned 4 R's are the system that we use in crop nutrition to address sustainability. And in order to be taken seriously as a sustainability system, we need credible metrics. Reporting not only just what we do, or what we are attempting to do, reporting our actual impacts. And in regard to that, what we're doing is engaging other sustainability organizations like Field to Market, like the Canadian Roundtable for Sustainable Crops, to ensure that we are in alignment with our metrics with regard to what they are doing as well. So when I've looked at the sustainability metrics for crop nutrition in the industry, we came up with this scheme, putting in our metrics into 3 categories of enablers, actions, and outcomes. Enablers are what we report in the industry in terms of the extension of people and professionals that we employ, the infrastructure we provide for information dissemination, and the investments we've made in research and innovation, and the efforts we've made in stakeholder engagement. That I will put aside for today because my focus is really going to be mostly on the outcomes. I've divided, we came up with this scheme of about 9 outcomes that address everything that fertilizers do for for humanity globally, essentially. And when it comes to phosphorus sustainability in particular, it's the first 4 that are important. The first 3 are very key to any farm operation. Keeping up the farmland productivity, crop yields are important. Then the soil health. Soil fertility is an essential component of soil health, and that is maintained by soil fertility as well. Nutrient use efficiency is something that every farmer is concerned with in terms of maintaining profitability, and it's simply productivity in relation to nutrient use. And then, in addition to those first 3, we emphasize all 3. We'll make a lot of progress in terms of the environmental impacts as well. But not every environmental impact is controlled by simply emphasizing nutrient use efficiency. In some instances, it takes only a very small amount of nutrient loss to have a very big impact on water quality, and sometimes it's not all about rate. The timing and placement of exactly how we're applying the material can have a big impact as well. So in my first example area, you've seen a slide this morning if you were in the plenary session of Lake Erie when it's affected by algae, and those kind of blooms have been happening with an increased severity and extent since about the year 2000 or so. You can see in that green area there is the Western Lake Erie watershed. It's a lot of very flat, heavy clay land. It's a very productive corn and soybean with a little bit of wheat cropping system. Most of it is tile drained. Yields of corn are often in the neighborhood of 10 to 12 tons per hectare. Soybeans are actually the most dominant crop and very profitable as well. But this region is prone to runoff from these soils because the infiltration rates are limited by that clay texture, and that does happen. So now if we look at Lake Erie's history, if we go back to the 70s and 80s, we had a big problem in Lake Erie, and a large part of that was unregulated sewage discharge. And so we reduced the total loading to the lake from around 25,000 tons a year to about 11,000 tons per year in total, and we attained that by about the mid-80s. And the last conservation practice added was that to agriculture, where agriculture shifted from moldboard plowing and intensive tillage systems to a more conservation tillage approach, where some farmers went no-till, some farmers went with chisel plow tillage instead of the moldboard plow. and that was thought to limit soil erosion and seemed to be in line with contributing to reduced phosphorus loadings. And for a time period, the actual loading, this is actually data from the Maumee River, dissolved reactive phosphorus, and the load is figured out here in terms of kilograms of P2O5 per hectare of land in the watershed. This comes from a recent paper published by Helen Jarvie with other co-authors, and she basically looks here, the cumulative load works out to about 0.4 kilograms of P2O5 per hectare per year. Very small relative to rates of fertilizer addition, which could be 40 kilograms per hectare per year, relative to crop removal, which is on the order of 40 or more kilograms per hectare per year. What's changed, we don't know why, but since around the year 2000, the rate seems to have almost doubled the loss of phosphorus. So here's our water quality metric telling us that something has gone wrong, and it's quite likely in the agricultural system because this watershed is dominated mostly by agriculture. The largest city in this watershed that are included in this data would be Fort Wayne, Indiana. And when we look at another metric that we're using, and IPNI calculates this in a product that we call NUGIS, we look at the crop nutrient balance. The orange bars represent what the crops are removing in that total watershed on the per, I failed to convert this to kilograms per hectare, but it's ballpark the same in pounds per acre. Okay, so you see the crop removal trend is increasing over the time period from 87 to 2012. The inputs in terms of manure applied to the land, and in the blue bars, the fertilizers applied to the land. The fertilizer input has actually declined somewhat, and the balance is actually more often in deficit than it's in surplus. There is variability from year to year, and of course there's variability within the watershed. Some farms may be in surplus, other farms may be in deficit as well. But what this is suggesting is that we don't have an overall excess loading, immediate loading issue that is contributing to this change here. So our hypotheses as to what's causing it, well, we do know that 50% of this fertilizer is broadcast onto the land and not incorporated within 7 days. If rainfall occurs immediately after application, we know that the runoff will be enriched in P2O5. We don't really know by how much. We have research underway to try and quantify that. So this slide is to illustrate that project. It's a very complex project, and the industry is investing about almost $250,000 per year in this project, which involves a number of edge-of-field monitoring sites, catchment monitoring, modeling of impacts on the lake, as well as surveys of farmers and socioeconomic surveys as well. And that investment is shown as a serious industry commitment to solving the problem. So the findings of that research so far is that incorporating fertilizer reduces phosphorus loss in tile drains by 45%. It's a little bit controversial because this means we are going a little bit away from conservation tillage. We have to find a way to get the phosphorus into the soil, and that may involve some more tillage than some people would like. What we're seeing is stratification of soil test phosphorus. Conservation tillage has an unintended consequence that eventually phosphorus builds up in the top layer of soil, the top few centimeters of the soil. We did find that Helen Jarvie's research found that 1/3 of that increase could be attributed to the fact that the river is flowing at increased rates, largely because the weather has shifted. We're getting more intense and larger rainfalls. Our farm surveys are showing that farmers are aware of the issue, they're concerned about it, and many are willing to change practices, but that practice change may take some time. When it comes to rate adjustments, they can be done fairly quickly. When it comes to changing placement of phosphorus, it usually means for the farmer investment in a different strategy for application. The other finding is that collaborating brings rewards. What we found with this program, we also have, in addition to the research, a program where we're certifying ag retailers for recommending for our practices to their growers. This was a multi-organization collaboration that developed the program. because it involved ag retailers, environmental organizations, fertilizer industry associations, including my own, the government agencies, farmer organizations, and land-grant universities. And what the program involves is a set of criteria related to source, rate, timing, and placement of nutrients that growers are obligated to follow. For example, if you want to be a 4R certified ag retailer and the farmer is telling you, I want you to come and spread that nutrient on my soil, it's because it's February, the soils are frozen, your machine won't get stuck. Well, sorry, we do not apply on frozen or snow-covered soil because the risk of runoff is too high. And they needed this program because if they didn't get some mark of approval that gave the good, solid reason to the farmer why we're not doing this, they would lose the customer because the customer would go to a dealer down the road who would offer to do it for them. The program's been a remarkable success. It requires the ag retailer to keep auditable records and be audited every year. It costs them to join, it costs them to be audited, and they often have to hire somebody to keep the records. Yet, in the space of 3 years, 38 branch facilities have been certified. They reach almost 1 million hectares, most of it in the Lake Erie watershed. And essentially, all the program gives them in return is the right to display this logo, the 4R certification logo. The value of the program was demonstrated in August 2014 when the city of Toledo declared a do not drink advisory on their water, and it was widely publicized around the world, and the fertilizer industry was converged upon by the media asking, what are you doing about it? And we could, instead of having to defend ourselves, we had our collaborators to attest to what the industry was doing to prevent issues like this, and we had been at work at it long before the incident occurred. The practices that we're putting in place and the programs we're putting in place, we expect the impact to increase over time. It's difficult to show actual impact in a short time. How much time do I have left with Venezuela? I'd like to give at least 5 minutes to Africa. And so here I'm speaking on behalf of my colleague. I have to be forthright and say I've never been to Kenya myself. Because we have this very fascinating program there that also uses the 4Rs and has been successful in getting information to growers. The situation there is completely different. Instead of a big productive system that's being threatened by environmental concerns, we have a situation where in many instances the main staple crop, maize, is being grown, and it's being grown at very low yield levels, unsustainably low, depleting soil fertility. We have unbalanced fertilization, wrong placement, wrong timing. We have poor agronomy and very little information source. So what we're trying to do is address them with a 4R program. And the program had essentially 3 components. They started with 4R learning sites, started with plots in the field, managed by researchers, but in the farming situation where they compared farmers' practices with enhanced practices that involved application of NPK fertilizers, and also was set up with an omission plot design so we could tell which nutrient was limiting. Ideally, we'd come in with a soil analysis program, but we don't have good soil analysis in Africa. So this is a very good alternative because what we're doing is evaluating the soil's fertility through direct nutrient omission plots here, demonstrating the efficacy of fertilizers. Then from those learning sites, knowledge products were developed as well, and then for our training and capacity building at the same time. So what have our results demonstrated? These are just examples, each from a different farm. When we aggregate the data, what we can see is that there is variability from farm to farm as to which nutrient is limiting the most. But in general, you can see from the control with no fertilizer applied compared to the NPK treatment with fertilizer applied, we do have a very strong response to nutrients as long as it's coupled with good agronomy. The knowledge practices, products that we developed include handbooks, pamphlets, and many other materials This was developed with funding from another of our member companies, Agrium, as well. And then there were also a lot of farmer meetings, starting with the neighbors to the actual pilot project farms, and with a lot of partners as well. It included training of master's students and engagement with policymakers. So, and partnering with the seed and fertilizer companies was also very important. So in the end, we attained regional recognition for our nutrient stewardship with our collaborating organizations. So there you can see, at least, even though the biophysical environment and the cropping system was totally different than Lake Erie, collaboration was important. 4Rs was a great rallying point for these organizations. We had policy influence. We influenced other fundings like the Cereal Enhancement Program in Kenya, and we achieved a fair amount of national media outreach through print, radio, and television media. And then I know they have a number of videos about this as well, and are hoping to continue expanding this program. A brief word about another activity in North America. We recently released a summary of a workshop, a science workshop, where we tried to spell out to the extent we could for our phosphorus management practices for a diverse group of cropping systems of North America. This again was done in collaboration with the Field to Market Sustainability Organization. So if I can sum up, phosphorus sustainability issues are addressed by the current industry initiatives implementing 4R nutrient stewardship. And there are certainly more than just the two examples that I've shown today. In the 4R, in the Lake Erie watershed, we built public trust by engaging environmental NGOs, agri-retailers, and farmers and getting them to work together. The Africa program, it proved successful in disseminating nutrient management knowledge. So, Mr. Chairman, if I've left any time for questions, I'd be happy to entertain them.
Thank you very much, Tom. I think we have time for a few questions for Tom. I don't think you should just disappear like that without entertaining some. Yes.
My question is, in the Lake Erie watershed, you showed the equal amount of manure and phosphorus fertilizers applied.
Oh, well, no, that would be a different, I may have gone too quickly. Because if we look at the blue bars.
Okay, yeah, much.
And we look at.
So fertilizer is much more than manure.
Yes, in this watershed.
But to some extent, you may believe that there is more manure applied because it's also a high livestock density region, isn't it? So the incentive for applying more manure than reasonable, than sustainable, couldn't that be a reason for the increase in losses?
This is an interesting point because if we look at that region, this is part of Michigan, part of Indiana, and largely northwest Ohio. If we go into Ontario, in this section of Ontario, and if we go into a large part of Michigan, you will see a higher livestock density there. That's reflected in both soil tests, average for the states and provinces, and in the nutrient use as well, in the nutrient balances that we've computed. But these nutrient balances, the manure excreted here, this is actually recoverable manure. It is not all manure excreted, but there are coefficients that deal with the fact that not all manure is actually applied to land. So the actual volume of manure may be as high as twice what is shown here is in the watershed, but some of it is not being applied to land. There are laws preventing farmers from putting it in places where it will directly run off to rivers. So still we, in the fertilizer industry perspective at least, feel very hesitant to point the finger at the animal industry. Yes, and I don't know if you saw it on the one slide. Our slogan that we developed was, we all play a role. Because this is always a question as well. Farmers often feel that the issue is being attributed 100% to them. But essentially what we're recognizing is that agriculture plays a role here. The plans, programs, and loading reduction targets that have been developed have recognized that the sewage treatment needs to do more and go further as well. Thank you.
It's time for another quick question. Okay, seeing none, maybe I'll just take the opportunity, Tom, to let you know that OCP is driving sustainable agriculture in Africa. And some of the work that you've done in East Africa, applying for how to replacement effect, and looking at how to increase phosphorus use efficiency or fertilizer use efficiency in general. We are interested in what you're doing, and there will be plenty of opportunity in other sub-Saharan African countries to be able to work with you and see some of the things that are interesting to our needs. We're interested in soil fertility, so we want to really get to the basic of fundamental agriculture in Africa. So understanding the soil characteristics is key for us, and I think maybe during this session, or the session tomorrow or the after, you're going to hear more about OCP initiatives in developing digital soil fertility in Africa. So we look forward to working with you.
Thank you for that point. I agree with you 100%. And in fact, everything I've shown you today is supported by OCP as a member of IPNI as well. So thank you for pointing out my failure to mention OCP as a strong supporter of all this work. Thank you.
Thank you very much. So please thank Jeremy, thank you John for that wonderful presentation.
Also for farmers and we for food security and national economy. Those climate change lead to abundant or reduced oilseed crops extent, which have a negative effect on the global cropping system, since those crops, oilseed crops, play an important role in rotation with cereals, which are the most strategic crops in our country. Nowadays, there is a political will in Morocco to develop and restart oilseed crops to improve the farmers' income and to ensure edible oil food security by increasing national oilseed production. So to support this will, challenging facing the increasing abiotic stresses, we should develop and cultivate various tolerance varieties, diversify oilseed crops, and then to introduce and adopt new alternative crops. So the objective of my presentation is to give you a brief overview on the main and recent achievements to face the most important abiotic stresses increasingly observed in Morocco, mainly for rapeseed, sunflower breeding as existing species or crops in Morocco, and then for new introduced crops as alternative oilseed crops in our country. So I will begin with sunflower. As you know, sunflower is traditionally cultivated in Morocco as a spring crop, and this have negative effects on the growth of this plant, mainly during flowering and grain feeding, which coincide with droughts and heat. And as a result, sunflower yield decrease seriously and will further decrease in the future. So in our institution, we developed early planted sunflower or autumn sunflower as a new strategy or a new crops, new oilseed crops as a means to overcome mid and end cycle droughts and those to improve the production of this crop. The breeding works carried out during the 18th and 19th of the last century led to the release of the only one autumn varieties registered in 1999. It's called Ishraq and is a winter cold tolerant and highly productive. It's cold tolerant, but also is a drought tolerance. And its average CDL is almost 3 tons per hectare in comparison to 1.6 tons per hectare for spring classical traditional varieties. So the current research continues to develop new sunflower germplasm tolerant to abiotic stress. So we are searching winter cold and drought and agronomical performance. This would be the basis for selection and of new improved varieties better than the existing one, in Ishraq. And the promising genotypes having expressed more performance than the Czech in terms of CDL, oil content, and flowering earliness were identified and selected to constitute a new population variety. These genotypes could be considered as valuable genetic stocks for autumn sunflower breeding program for the next future. This table to show you the performance of Ishraq and the threshold for selection for the interesting parameters from initial vigor to 1000 CDL. So we fixed some threshold for selection, and those plants are expressing more performance than Ishraq are selected to constitute a new germplasm. This to show you the pool constituted after this selection for the parameters. Interestingly, we have some common genotypes or plants in different for different parameters. So for rapeseed, actually rapeseed is the second crops, oilseed crops after sunflower cultivated in our country. Is one of the most important sources of vegetables, oils, and protein-rich meals in the world. It's well adapted to our local conditions and is more and more cultivated in favorable areas. But as a result of increasing abiotic stress such as drought, heat, and water lodging, seriously threaten rapeseed. The production for rapeseed is seriously threatened. So, and in this context, germination and early seedling growth are the most sensitive stage for drought and waterlogging. Why I'm talking about waterlogging? Because in some main region where we are cultivating sunflower, for people who knows Morocco, is the Gharb region. Gharb region is one of the most important area for rapeseed cultivation. But in the last years, we observed a high frequency of waterlogging occurring in that region. So we are obliged to select to breed some material, some varieties. I mean, that could be tolerant for waterlogging, mainly during germination and early seedling growth stages. So, for second thing, more important thing is the flowering and green feeling, that they are very sensitive to drought and heat. Like as the most of crops cultivated in the world, the flower and green feeling are very sensitive stage. So seeds exposed to unfavorable conditions like drought and waterlogging states may have to compromise the seedling establishment and those the crop production. So we are obliged to maintain high seed germination percentage and elevated seedling growth under drought and waterlogging conditions as one of the most important objectives in our breeding program. For rapeseed germination under drought, we observed that drought stress affected early germination and early seedling parameters, namely germination percentage, germination rate, mean germination time, shoot length, and the root length. And the variation among the test varieties is an indicator of genotypic differential for drought tolerance in rapeseed. And we selected two varieties which germinated better than the others under severe drought conditions. And even INRAS sees that H3 showed the best seedling growth, I mean root and length in such stressful condition, which is very interesting for us. In this figure, we have here the level of stress by osmotic potential of PEG solution, reflecting the severity of the stress. Here, for -9, it's the most severe stress, and one could observe that H3 and H2 varieties are the most tolerant, even for the intermediate severe the stress. This for seedling growth is for shoot length. Here, once again, the varieties H3 and H2 express the most important performance, mainly H3. H3 was the most important here. So it's a promising variety for germination under this showed for the same thing. We have the same result, but for seedling growth, H2, H3, and H3, H2. Usually they are the best one, mainly H3 varieties. Here for lodging, that was for drought conditions. during germination and early seedling growth stage. Here, just for waterlogging, we found that the waterlogging, like drought, significantly affects most of the studies parameters for our varieties. Germination and post-emergent seedling stage were the most sensitive to waterlogging stress conditions. Variety differences in tolerance, intolerance to waterlogging conditions were significant, and INRA CZH3 was the most performant and tolerant to waterlogging conditions in different plant stage, including germination and early seedling growth. So interestingly, this variety was the most tolerant to both stresses, drought and waterlogging during germination and early seedling growth. And in the future, we will test it for drought tolerance for other stages. This table to show you the difference between the H3, H2, and the other varieties. Here, CDL per plant, the experience the most interesting CDL under waterlogging conditions. This photo to show you the difference between H3, which expresses the tolerance under the waterlogging conditions, and the other varieties here and here. It was the most performance. So usually for the existing oilseed crops, breeding for only flowering varieties having short duration cycle would be a good strategy to escape droughts and mainly heat stress happening or occurring during flowering time. We have developed some novel material, mainly mutant material, by mutagenesis breeding using EMS technique. So many mutant lines were developed and they are exhibiting a contrasting profile compared to the original material, which was the H2 varieties. So genetic progress, a considerable genetic progress was particularly observed in terms of seedling initial vigor, flowering earliness, branching, and number of pods per plant. And the most interesting mutant lines are MUT2 and MUT3, as it is shown in this table. MUT2 have the shortest cycle between between emergence and flowering, and here he had the highest number, the average branching per plant, and the highest number of pods per plant, and the second number between after MUT5. So MUT5 and MUT2 were the most, and are conducted in our breeding program to develop novel varieties, which is performance under the drought conditions. Here to show you the difference between MUT2 at the early flower and the wild type in H2 in terms of earliness, flowering earliness, and including in terms of tolerance of drought and heat. Our current observation in the field showed this MUT2 are more tolerant than wild type in terms of heat and droughts. For safflower, the third existing oilseed crops, novel germplasm was developed so here we have experimented several varieties from different geographical origin in contrasted environments with different years, with different planting dates, and under full irrigation and dry water regime. And we selected some acquisitions having maintained high seed and oil yield in urban environment tests. So, after the presentation of the existing oilseed crops, I will say just a word on the new brassica species introduced in Morocco to be used as alternative crops. We are talking mainly about brassica rapa and Johnsia. They are oilseed crops more resilient than brassica and napus, due to their higher tolerance to some abiotic stress like drought and heat. And even though brassica napus and rapa exhibited almost similar response to water use under semi-arid conditions, but there is a significant intolerance to air temperature. For rapa, the optimal daytime temperature is 28 degrees versus 20 degrees for brassica napus. And brassica rapa has a shorter life cycle than brassica napus, starting and finishing its flowering 2 weeks before. That's the turnip rape, brassica rapa, is considered to be a potential source of drought tolerance for rapeseed. We are making crosses between two species to introgress the interesting genes from brassica rapa to brassica napus, mainly in relation to drought tolerance and heat tolerance. For Johnsia, the same thing. Its optimal daytime temperature is higher than that of brassica napus, 28 degrees versus 20 degrees. And by increasing the day temperature during flowering stage to 35 degrees, CDL was reduced by 34% for brassica Johnsia, whilst it's reduced by 93% for brassica napus. So Indian mustard was considered as resilience or adapted material to stressful environments associated to low rainfall, high temperature, and late sowing, and it could be adopted in our conditions. So compared to rapeseed, Indian mustard shows strongly early vigor, shorter pre and tessis phases, and greater dry matter production. And he produced more pods per plant, and he is shutting resistance. This preliminary trial of these new crops, as one could observe, they are budgeted to ensure selfing, as they are allogamos species. So they are the first observation indicated that they are very well adapted to our conditions, and now we are in the second years of observation, and they are confirming their adaptation. They have even more adaptation to our local compared to brassica napus. As a conclusion, we can say that there is an increasing edible oils insecurity risk in Morocco due to aggravated abiotic stresses as a result of climate change conditions. To cope with climate change and to enhance edible oils food security, it's very important to diversify and develop adapted and resilient oilseed crops, and to adopt a wider range of tolerant and stable cultivars, to develop and release autumn sunflower varieties and germplasm as a possibility to shift planting period from spring to autumn. The development of tolerance to rapeseed variety tolerance to drought and water lodging during germination and early seed growth were identified and will be used as promising germplasm. Rapeseed early flowering and productive germplasm was developed by mutagenesis breeding. Safflower germplasm adapted and productive under contrast environment conditions were identified and selected. And novel brassica species, mainly Johnsia and Rapa, more resilient and adapted to some abiotic stress, were introduced and recommended as alternative oilseed crops. As a prospect for the existing crops, the promising varieties and genotypes will be tested for direct tolerance to drought, heat, and water lodging occurring in various adult plants growth stages: rosette, rape growing, flower buds, flowering, and green filling. The selected germplasm will be integrated in our breeding programs. For the introduced crops, they will be evaluated under stressed conditions in comparison with the existing crops for water use efficiency, nitrogen use efficiency, and phosphorus use efficiency. And the best of alternate materials will be demonstrated and disseminated to farmers. Thank you very much.
Thank you very much, Dr. Abdelrani, for this presentation on breeding programs. Now, before we break for coffee, if there are any questions from the floor to direct to the speaker, they will be willing to reply to your questions. Yes?
My question goes to the first speaker regarding soil testing. You presented two options that are available for Moroccans to test soils. One is where testing is subsidized and they can go and access it. And where the program also is doing what we call soil mapping and providing information. I would like to know from that option of soil mapping, because I think that's the best way to go, because even when it's subsidized, some farmers may, number one, not still afford it, or number two, may not really know what they need to test. But when you go the option of soil mapping, it's the best way to give an idea of what's lacking or what's limiting in an area, and then maybe advise farmers on what else they could test for. Out of the two options, from your own view, which one looks more promising for Morocco, and also which one are farmers in Morocco looking more to apply or use? Which one has more adoption? Thank you.
Question, please.
First of all, I want to thank all the speakers for sharing with us this very precious information. I have one question that I am addressing to our Professor Moghli. As you have mentioned, there is many actions which has been taken to improve the productivity of cereals in Morocco. You have mentioned that the role of insurance, the role of ONCA in advising farmers, the role of laboratories, and so on. But if we want to link all these actions to what is implemented politically, I'm referring here to the Moroccan Green Plan. If we analyze a little bit what is implemented in this plan, we could clearly see that this plan wants to reduce the surface which is devoted to cereals in Morocco. And moreover, they give more importance to high value or cash crops like tomato, potato, and fruit trees. So how can we link what you have said to what is implemented politically.
The question, please.
Well, thank you for your presentations. And I have a kind of question to Dr. Morley. You showed that for around 4,000 hectares, that it is possible to increase the yield while applying like a high fertilizer rate compared to the national level. My question is, the fertility map can be used as a tool to achieve this goal, or through the demonstration trials that you had achieved, we need to apply a different rate that was mentioned in the soil fertility map?
Okay, let's. Mohli,
I need to answer, otherwise I will forget.
Before we move to another question, okay. Professor.
Yeah, for the first question about soil fertility map and how the two strategies about crop fertilization. My point of view is that in Morocco, I say all the time that we have an agriculture with two speeds. We are farmers, really intensive, and they do soil testing at soil testing labs, and they have precise fertilizer recommendation for their crops, for their plots, for each plot. And these, we developed recommendation programs for different crops, not only cereals, and they're used otherwise by our lab, because we have soil testing labs at the university, and other soil testing labs. So the fertility map can be used two ways. If the farmer does not have any information, he didn't perform soil testing, he can go to this area and just click on the area where he is. He will have an average soil test content, phosphorus, potassium, and organic matter, and then he can use the application where there is that's in the fertility map, and he will have for. We ask for three things. First, choose the spot, and he will have automatically the average phosphorus, potassium, and organic matter content of the soil, and he will choose then the crop, and then the yield potential, the objective, and then he will have how much does he need to add nitrogen, phosphorus, and potassium, and even more than that, because farmers, a lot of farmers, because I work a lot with farmers, they don't know what is NPK and how they go to which fertilizer to use. In that application, he will have also the kind of fertilizer he can go and buy. If the farmer has his own soil test results, he can use the same application, just introduce the numbers he got from the lab, and he can use the application. So it's used for different kind of farmers. And we have the third one I talked also, farmers who are far away, who are not aware of the soil testing. We develop just a general regional formulation which is closest to soil needs and crop needs. So the second question about the Green Morocco Plan, which is a huge program, and what I was talking about. Yes, the Green Plan, it's kind of, it's political view, we can talk about it, but the objective is just we have a lot of areas dedicated to dryland cereals. And the idea is that why not decrease the area, but what we should do, increase yields. And that's what I'm working on, is how can we, with a smaller area, not small, smaller area, we can produce more than we're producing now. And this gets me to the third question of Khalil. You see what I'm presenting here, because the average yield, it's about 1.3 on 10 years at the national level. And the other graph I presented, they're not demonstrations. These are real farms farms, 4,000 hectares, and it's not something kind of potential or what we can do. It's done. We have about 3.5, 3.6 metric tons per hectare on average of 10 years using these levels of fertilizers. And I'm myself who has been advising these farms, and that's why I didn't go to trials, but the real world. It is possible because it is done, but I must say that it's not, we don't have this kind of increase in yield just because of fertilizers. No, I was talking about BMPs, fertilizers, pesticides, good work, soil tillage and stuff, and that's what we need to go.
Okay, okay. This is good question. Yeah. Use the micro.
Sorry?
Mic, please.
Does it work? Okay, can you hear me? Okay.
Yeah.
Zheng Li He from University of Florida in USA. I have a question, maybe it's more common than a question to the second speaker, Dr. Zhang. It's a very good presentation, and I really enjoyed it. However, about the definition of nutrients use efficiency, I have a different opinion, and I would like to discuss with you. You define the nutrients use efficiency as the, nutrients taken up by the crop or harvested product divided by the total fertilizer input. However, as you are aware, actually most of the crops, they actually obtained 70% of nutrients from soil, not from fertilizer. So if you just simply use the total nutrients in the plant divided by total input, then you may overestimate the use efficiency of each nutrient. How do you think about that?
Thank you very much for the comments. So I get that comments a lot from soil scientists. So it's really about what's the system boundaries that you are looking at, and also what is the time scales that you are looking at. So like take nitrogen as an example for now. So if you define the cropland as a system that you are investigating, the soil is considered as an internal, soil is considered as internal components for the crop production, and you're looking at how much of the nutrients coming in and how much nutrient come out. And it is possible that for, say, 1 year plantation or 2 year plantation, there are some nutrients are coming from soil, like mining from the soil, or coming from the reserves from previous years. But over a relatively longer period of time, say 10 years or 20 years, the nitrogen level within the soil can, so the level of nitrogen in soil change. So the changes of nitrogen level in soil is relatively small compared to the total nitrogen input and output, especially in the fertilizer intensive areas, say US or China, because the magnitude of the input from fertilizer could be 100 kilograms per hectare, or even higher, but the average nitrogen content in soil, it cannot, and the changes could be on the 10-year time scale, the changes could be less than 1 kilogram per hectare. So it's a relatively small component if you consider, say, 10-year or a longer period of time. I hope I answered your question.
Okay. Any other question from the floor? If not, we are going to break for coffee because there is another session, and we thank our speaker, and let's have a clap to them for the session. And thank you very much for attending this workshop.
You can do 2 meters high, and you can use like structured packing as an example. That can make the tower as small as possible and theoretically save you a little bit of money at the beginning, but now you've got no flexibility. If you use standard saddles, you can always change them to high pressure saddles or low pressure drop saddles to debottleneck, or structured packing to allow a flexibility for a future debottlenecking exercise. That's why we make it, because the cost of that extra height is very small compared to the cost of the plant of the tower. The tower diameter, again, sized conservatively. Mist eliminators are minimum be 5% extra. Brick towers, we put 2 layers of brick backed by PTFE. A lot of vendors only do 1 layer. The reason for that is, if the acid gets to the liner, it'll eat it away. If you have 2 layers of brick, it takes an awful lot more time to get there. So the towers are a lot more reliable and will last 25 plus years versus 10 to 15 years. The gas inlet nozzle has low velocities, better distribution, better reliability of the tower. And the metal thickness, are designed for earthquake loads and wind loads, but you have to make sure you consider the weight of the acid, the weight of the trough, the weight of the candles, the weight of the acid in the candles, and the weight of the packing in your calculation. A lot of vendors don't do that. Out distributors, Comedic's version of trough distributor, which makes a big difference, is the ISOFlow trough distributor, which is an orifice type shown here, and our latest development is called the Swift Lock system, which we take two banks of tubes and attach them with one simple clip in a perfect location in about 3 seconds with any one of these banks. So it makes it very easy to install or repair or remove anytime in the field. And that's a patented technology just from this year. The tower performance issues that can lead, that can also lead to extended plant issues. So you can have emissions issues, you can have downstream corrosion, you can be running at lower capacity, you can have tower leaks and maintenance, and then you can lead to a shorter life of the tower. End result is 2 to 3% loss if you don't design the tower conservatively enough. Gas heat exchangers also can have the same issue. Typical issues you have with them: tube plugging, sulfate buildup, tube-to-tube sheet failure, tube leaks, acid condensation. What you're seeing here is some sulfate buildup on the gas and just inside of the gas inlet of the cold exchanger. And here is the result of what that will do: is leak your tubes and put a whole bunch of leaks, causing you issues with emissions. This is pretty common in a lot of sulfur-burning sulfuric acid plants as well as metallurgical sites. And the reason for it is that the typical packed bundle designs have dead zones. And these dead zones have very low velocity and low heat transfer, which means the tubes will grow more or less, leading to greater stress in the unit. That greater stress pulls on the tube-to-tube sheet joints to rip them apart, and gives you leaks and corrosion. Radial flow gas exchange is a little different. You've got the gas comes in the bottom, goes through perpendicularly through, hits this plate, goes perpendicularly through the shell, goes through a gap where there's no tubes, and then it goes perpendicularly again. So you end up with completely radial flow, low stresses, and you end up with the welded tube-to-tube sheet joints on the unit, and really big units, a very reliable system. So radial flow exchangers, we patented them in the 1980s, early 1980s, and in sulfur burning plants, same service, no changes to the plant, replacing the existing. We've had 25 plus years and they're still running with no maintenance on them to date. Units versus less than 10 years for the units that they replaced. End result is, by using radial flow gas exchangers, which are better designed for these big plants, you can get 1 to 2% increases in availability in site. Other equipment, look, all the equipment in the plant can affect reliability and availability. To maximize, you've got to select good equipment, and you got to appropriately integrate it in the plant. The technology firms should be used to provide basic engineering and core detailed engineering to the plant and key equipment. The client will get stronger guarantees and remedies because they live in a greater scope. They'll get lower construction commissioning costs because those people will be on site making sure it's done right. And you're going to get a better and more available plant, a better and reliable plant with higher availability percentage and lower commissioning time. Plant layout. Plant layout should be designed to be accessible and maintainable. Way to get that is get the vendor to give you a 3D model of the plant that they built with the same design. It's easy to get. They've all done it before. Have their people look at it. See if you can get inside the plant and maintain it the way you want. And realize that the changes in design from one layout to another is less than 1% of the PIC of the plant. The benefits are huge for the long-term maintenance and stuff. Plant flexibility. Plants get older. They will have issues. Steam equipment, they get foul. The catalyst, it's going to get old, it's going to get less reactive. The packing builds up sulfate. The pressure drops are going to change. You're going to have different weather conditions. So when you have that, when you're doing the evaluation, check the PNIDs, check the bypasses around the equipment, and make sure the flexibility and the valving is there to allow you to do it in the different operating conditions. Don't just say, I want maximum capacity at this rate and these emissions, and I don't care about any other operating mode of the plant. A lot of RFQs are written that way. You want to have all of this covered. Plant flexibility. Well, another thing on that is heat recovery systems. Heat recovery systems are present and they make a lot of money for fertilizer sites. There are two different real approaches that are made. One is to make medium pressure steam. You've got from the inter-tower waste heat, and you've got the MECS HRS system, you've got the Comedic's Alpha system, and you've got the Altec Hero system. All of them can do it, all of them have done it, and they all work really well. Another choice is like Rene just presented on the CS, the desalinated water system, where you can make hot water to make desalinated water. Both work. But the thing that really matters is, no matter what this is, what kind of money that you get out of these heat recovery systems is trivial compared to the profits that you make from the acid. The steam, the power, and the acid. So effectively, you've got 3 to 5 weeks, that kind of number, of profits. If you shut down your main plant for 3 to 5 weeks, you've lost all the profits you made off the heat recovery system in a year. So make sure that you design the system so that the main plant can run when the heat recovery system is off. It's just prudent for the plant recovery. So final conclusions. Sulfuric acid plants can be and have been operated for 30 plus years with an availability over 98.5%. The additional cost in TIC of comparing those plants to what was done as a real cheap site is often 0 to 10% over the minimum acceptable. So, what is there, if you design a plant well, if you build it correctly, if you think ahead, what are the things you get? Well, your commissioning time at 100% is usually less than 21 days compared to 4 to 12 months in many other sites. The plant repairs, because if you design it and build it right, are much less than 1% of plant TIC in the first year of operation versus often 5 to 15% in a less sophisticated setup. Plant starts and stops are 7 or less compared to 30 to 50 when the plant is having trouble with first trying to get commissioned. Equipment designs are more reliable, meaning that the equipment lasts 15 plus years before any major repair is done, and compare that to 5 to 10 years where a big equipment is actually being replaced in some of these sites. Lower OPEX, lower emissions, due to equipment issues and bypassing, and effectively the plant's easier to run for the client for the long term. So, the value of the additional production, reduced maintenance, ease of operation, and reduced commissioning time and repair are typically 3 to 10 times the difference in TIC between the prudently designed plant and minimized as cheap as you can get it. The most economic plant fundamentally is the one that's built on time, on budget, prudently designed, and has the minimum time of commissioning and the least operational tolerance in the first 2 years. So that's what the customer should be looking for, that last statement. Final conclusion is basically, what's the trick? How does the plant owner know how to achieve this prudently designed plant? The answer is, know what you're getting from the vendor, which meet your needs. Get clearly stated guarantees with surrounding remedies with failure, performance, reliability, availability, emissions, delivery time, commissioning time, and at the end of the day, fundamentally do it once and do it right. If you do, you're going to have a lovely plant you're going to love for the rest of your life. That's it. That's all I got there.
So we are behind schedule, but we can extend also to 3 questions. So please.
Thank you. Thanks, everybody.
So, the next paper is the innovation in sulfur handling, and will be presented by Mr. Raiz Bashir.
Thank you, sir.
Thank you and good afternoon. I'll just take a minute and introduce myself. My name is Raiz Bashiruddin. I'm responsible for commercial functions at a company called Furnace Fabrica. We are an EPC contracting company with more than 4 decades of experience largely in the construction of sulfuric acid plants, amongst other things. We do other things as well, but about 1/3 of our business comes from the sulfur and sulfuric acid business. Unfortunately, there's no credits in there for the paper was co-authored with Mr. Nazri and also my colleague Altaf. Mr. Nazri unfortunately could not be here this afternoon, and so he leaves it to me to present. Mr. Nasri was the project director for this project that we're going to be talking about. He was the project director from Jacobs Engineering SA, who were acting as the client's engineer on this particular project. My paper is largely to do with the project which we've successfully executed here in Morocco at Jorf Lasfar, which is our company commissioned successfully in 2015 the new import and processing facility for sulfur for OCP at the JORF platform. Maybe I'll just take a quick slide to introduce the company itself, and I think from the next slide we get into the case study itself. Quick one, as I mentioned, Furnace Fabrica, we are an EPC contractor. We have been in this business for well over 40 years, since the early 70s. We're an Indian company operating out of India, but operating worldwide, and specifically, especially in the Eastern Hemisphere. We're quite active, but yeah, we are an India-based company. We have industry leadership out of India, especially for the construction of sulfuric acid plants, both sulfur burning plants and also metallurgical off-gas acid plants. Maybe about more than half of India's acid production comes out of plants built by us, based on different technology suppliers. We're also quite active in the sulfur and sulfur recovery, sulfur handling and sulfur recovery market as well. And what's quite unique is we have quite a lot of capabilities around heat recovery equipment, primarily the boiler systems. We are headquartered out of Mumbai. We've got regional presence in all the different regional markets in India. We have got international presence in the Middle East, in Africa. In Africa, specifically here in Morocco, we've been here since almost 9 years, close to 10 years now. We're quite active in the Copper Belt since about 15 years, in Zambia primarily, and in the Middle East and Southern Africa. We have captive fabrication facilities, both in India, also in some of our global markets. We're in the process of setting up a fab shop here in JORF, here in Morocco as well, and we have facilities in Zambia for the Copper Belt, also one in Saudi Arabia for the Middle Eastern market. We're not a very big company nor a small company, so we're about half and half, about less than 300 people based out of office locations and another 300 people on the field. And I think the field execution and the field oversight, construction management, it's quite a critical area. There's quite a lot of differentiated capabilities which can come out of those functions. We have, I think we've mastered and have been able to demonstrate, especially here in the Moroccan market, quite a lot of capabilities on specialized construction services, and which is quite well targeted towards process plants like sulfur and sulfuric acid. So I'll get to the topic on hand, which is the case study for the new sulfur melting facility, the sulfur liquefaction facility, which was commissioned in 2015 at JORF Lasphar. OCP are, of course, the world's largest sulfur importer, and naturally sulfur is a key input for their fertilizer value chain. It's one of the key, I would say, imported ingredients into the mix here. Naturally, all of this sulfur is going into and being converted into sulfuric acid, which of course is a key intermediate for the treatment of the natural resource here, which is the rock phosphate. We were awarded a contract in 2012. It was a lump sum turnkey contract by OCP to build a turnkey sulfur processing facility at JORF, at the JORF platform. The objectives, of course, were to produce a molten sulfur, liquid sulfur product with as little ash content as possible. Of course, the other major objective was to optimize the cost and risk through a well-structured lump sum turnkey project. We were successful with extensive amount of pre-bid engineering in this particular case. There was almost a year of pre-bid engineering on this project, and naturally, where in-house design and engineering and of course direct construction enabled us to control and manage a lot of the risks associated with such kinds of fixed price contracting arrangements. We of course touched and reached out to a lot of the key technology providers and equipment suppliers to be able to deliver such a project in an efficient manner and with state-of-the-art processes in there. I'll just quickly touch upon the project itself. This consisted of 4 trains of sulfur processing, right from handling all the raw sulfur into 4 lines of 100 tons per hour of processing raw brute sulfur into liquefied molten sulfur with a filtration step. The utilities, of course, the plant was designed for 4 lines of 100 tons per hour, as I mentioned. Nameplate capacity has been set at 6,000 tons per day, which really is, the 4th line is a redundant line. The utilities and some of the offsites have been built with the view of doubling the capacity of this plant in the future. The client, of course, is the OCP group on the JORF platform. Owner's engineer, as I mentioned, was Jacobs Engineering SA, who structured the contract and of course put the RFQ together and managed the oversight of the entire project to commissioning and handover. Some numbers not so interesting. Of course, this was really a fixed price lump sum turnkey. I mean, everything in there was within the scope of this contract, right from civil work to all the design engineering, supply of all the major equipment, construction, and the going into trial runs and commissioning. Just over 100,000 man hours of engineering went into this project, and the plant was successfully commissioned and handed over in September 2015, so just under 2 years ago. The plant's broadly split into 3 sections. You have, of course, the entire raw sulfur handling and storage areas, and then the main sulfur melting and transfer areas, and then there's the third stage, which is the critical stage as far as some of the product guarantees were concerned. There's a 2-stage sulfur filtration and then product handling area as well. So the solid sulfur handling section consisted of a whole set of conveying systems. There's a 4,000 ton per hour conveyor bringing in the material into the plant, and then we have a set of intermediate hoppers with feed hoppers with about 300 tons of capacity on each line. And then we have the belt extractors and the feed conveyors to the melting lines at about 100 tons, rated for about 100 tons per hour. The melting filtration line is, as I said, 4 streams, 100 tons per hour. There's a set of above ground conical bottom melters, high capacity melters with, of course, a downstream dirty sulfur tank with, which gets fed through an overflow from the main melter. And the sulfur is the dirty sulfur is pumped out of these dirty sulfur tanks to the filtration building. The filtration building has 2 sets of on each line we have 2 sets of primary filters, which are horizontal pressure relief filters, and then a secondary polishing filter, which is with ceramic cartridges, internal ceramic cartridges. There's also some interim storage capacity in there, and of course the entire utilities package, which is steam, condensate recovery, all the compressed air for instrument and for the plant air, raw water piping and potable water. Also the entire fire water network inside the plant was within the scope of the contract, including fire and gas detection as well. So here we have some pictures, and so that's the feed and shuttle conveyor for the phase 1 of the plant, which is the core feed conveyor is for 1,000 tons per hour. We've introduced, I think, in OCP for the first time, we've introduced also a very comprehensive fire detection system on the main conveyors itself. The fire hazards in a sulfur plant are largely in the solid sulfur section, where there's the potential for dust and even a dusty environment, creating conditions for some spontaneous combustion and explosions even. And so we of course have some separators in here, and then we have the main fire water pipe as well, which is continuously monitoring. We have a continuous monitoring system for fire detection on the main feed conveyors. With a view to neutralizing and any potential acidity in the melters, we have an online line dosing system also on the main feed conveyor. So what we see here is the line dosing station itself. This is how the belt extractors and the feed conveyors to each line look like. We were also the first people to introduce for sulfur handling dust control. So we have a dust control system where we are spraying certain surfactant based chemical sprays to control the dust, and So key points of, especially on the key transfer points, we have dust control in there. So of course the main melters themselves. So this is for the second section of the plant, which is where the sulfur is being molten and being pumped out. We have the melters are, there's 4 trains here, but each melter is an above ground melter with a conical bottom. The existing, or rather the existing facility both in Jorf and also in Safi in the port are actually below ground melters, and so we've actually called the melters above ground here, so it gives us easy access to the bottom of the melter for maintenance. Also from a drainage point of view, it's possible to drain the melters completely during any kind of periodic cleaning operation. The melting coils in the melter, of course, are modular in design. They can easily be removed and replaced, or even repaired. Each melter comes with a single agitator. So it's a 3D view of how the 4 lines look like. Then we go into the pumping step, which is the molten sulfur. It flows into a dirty sulfur tank through an overflow pipeline, and then the vertical submersible pumps which pump the sulfur out are actually installed in these pumps. So also there's a pre-coat step prior to filtration. So the pre-coating action is also happening in the dirty sulfur tank. So we have a very similar design. It's for the dirty sulfur tank, like the melters themselves. Of course, there's a smaller requirement. There's fewer coils required because the sulfur is coming in a molten form. So there's effectively just enough heat to be given to keep the sulfur in its liquid state. Pre-coating and pumping are of course the main functions of this step. The sulfur then goes over to the filtration building. We have a concrete building for the filtration with 8 primary pressure leaf filters. These are horizontal filters with a retractable dish end. Typical filtration cycles last from 16 to 20 hours. Again, filtration cycles would be a function of how much impurities there are in the sulfur in the first place. We were again these are fairly mature design filters. In our particular case, for this project, filters did come out of Europe, and these are very similar to the existing filters in OCP and all the other operations. We were the first to introduce secondary polishing filters here in Morocco for OCP. The secondary polishing filters, of course, bring down the ash content down to a sub 10 ppm level, 5 to 7 ppm in terms of ash content. But the most important function of the secondary polishing filter is it acts as effectively a security filter, and potentially also reporting in the control room through its instrumentation, but also catching up, acting as a backup filter in case there's any underperformance or just poor performance in the primary filter. We have some product sulfur tanks as well. I think it's more of an interim storage. So we've got again 2,000 tons of storage on the facility before it gets pumped out to the main tank farm. I think all the project was pretty comprehensive. So all the offsets and utilities were within the scope as well. That includes all the compressed air that's required, the entire steam circuit as well, both the diesel heaters going down to for reducing pressure to the rating that's within our project. All the condensate recovery and handling section as well was within the scope. I think what's fairly interesting is in addition to a scrubbing system for for the melters in the dirty tank. We also have some natural draft vent stacks to extract any of the, because again there's quite a lot of non-degas sulfur which does come into the market here in Morocco. So there's potential emissions out of the sulfur which need to be extracted and let's say let out in a responsible manner. So we have some vent stacks doing that. There's also a scrubbing system, a caustic scrubbing system, which is there in case some of the emissions are more tricky and more extreme. Electrical panels, all the buildings. So I think to summarize some of the highlights of the project, I think what we did achieve is of course try to deliver I would say best-in-class technology for this application within a fixed price lump sum kind of contract arrangement. And while we did succeed in delivering the project within budget, I think what we really take home and we're quite proud of is the fact that we've exceeded targets as far as value addition in the Kingdom of Morocco is concerned, and kind of local participation that was let's say achieved. So a lot of the construction itself was actually carried out by, I would say, about 80 to 90% of the workforce that was used in constructing this project and delivering this project was actually from Morocco. A lot of local skill sets were developed as well, and I think we even managed to develop a few key subcontractors as part of this project. And we're quite proud of the fact that we managed to exceed the local content requirements through deploying local crews as well for effectively all the piping and electrical work, instrumentation work, and also the firefighting system. Very quite early on in the project, the operational team was identified. It was a fairly fresh operating crew that was identified, and so there was well before, I would say almost 6 months before the project was to be taken over. The local crew was inducted for training and conducted about a month of classroom training for the final operating crews, and actually did maybe a few months of on-the-field training before the plant was actually operational. And in fact, the operating crew was in place when pre-commissioning and trial runs and final commissioning and handover was done. While we take pride in the local content that was achieved, I think this was also the area where we did spend and face the maximum number of challenges in terms of and that was an area where I think a lot of effort went in, both in terms of developing the Moroccan supply chain, but also in terms of adaptability to some of the ideas which are fairly new, both from a design point of view, but also from a constructability point of view. That's it. We missed one slide. That's right. I think quick conclusion. In terms of the project, of course, because of, again, the varying quality of sulfur which does find its way here to Morocco, the fourth line effectively is a redundant line, but it also is in there to be able to support sulfur of very poor quality. And so effectively, the project was conceptualized in a way that quite a lot of spare processing capacity was built in. And of course, I repeat myself here, but we were quite happy to have delivered all of that under budget through a fixed price LSTK contract. We could achieve and demonstrate during guarantees sulfur quality with the national intent of 5 to 7 ppm. The plant design provides for, actually we again get a good amount of feedback from the operating team that the plant is fairly easy to operate, and of course from a maintenance and from a housekeeping point of view as well, it's quite well laid out. There's, as I mentioned, sufficient redundancy and spare capacity with also a lot of standby availability provided, so that in effect with good quality sulfur, the plant's able to actually deliver about 50% additional capacity than that's what's called for in the nameplate. So you have months when the plant is actually, there is demand for the plant to deliver much more than well over 9,000 tons a day of production, and it's been doing it quite comfortably. So decongested layout, I mean, we were fortunate to have a greenfield site to develop, and so it's a decongested layout where the plant's quite well spaced out, a lot of access for both maintenance and also from a fire, and let's say attending to any kind of a fire type incident is actually quite easy. So that's, I think, right to the last point itself, the plant consistently delivering even up to 10,000 tons per day throughput when called for. So that's it, and quite happy to take any questions you have.
Thank you, Mr. Rais Bashiruddin, for sharing with us your great experience in Morocco, commissioning sulfuric acid plant in Jafraspa. So we still have time for 2 or 3 questions.
What provision you have kept for a fire in the sulfur handling system, as well as the fire on the melter, and what about the neutralizing the acidity of the molten sulfur?
Right. So we have. So I'll start with the last question. So we are using lime, dosing lime in the solid sulfur handling line itself. So of course the dosing itself is calibrated to acidity measurements in the melters themselves, and so lime dosing is what helps us provide form utilization. And as far as the firefighting, so of course we have a fire and gas detection system. So at the melters we have SO2 detectors on the conveyors themselves. At different points we have temperature sensors. We have this kind of a thermal temperature sensitive cable which is running across the length of all the conveyors. So any the cable is able to any kind of a fire on the conveyor, and the cable actually senses temperature differentials and is able to pinpoint where the fire is. And the first response would be the conveyor it trips, it's shut down, and we have it's a hooded conveyor. We do have sprinklers on the conveyor, and actually we're able to do localized sprinkling water for where the fire is in the to attempt to counteract any fire on the conveyor itself. And of course the possibility of fire is much more in the solid sulfur areas. And as I mentioned, as a countermeasure, we have done dust control and spray systems in all the key transfer points. And again, this is a fairly intelligent dust control system because we are spraying based on the amount of, let's say, moisture which is there in the sulfur in the first place. So it's possible to calibrate the amount of dust control
some picture when we harvest the maize. Drone
phosphate on the crop yield and especially on palm oil and maize, which is completely different of the impact of the used or the common phosphate on this crop. The second session will be presented by Dr. Elena Bosharkinova, a senior scientific officer from the Institute of Physical, Chemical, and Biological Problems in Soil Sciences at Russia Academy of Science. Dr. Bosharkinova will share with us many findings and recommendations on special P interactions which increase yield and prevent environmental pollution with regards to soil climatic condition. Dr. Bosharkinova, presently she's working at the Institute of, as I have just said, Physical, Chemical, and Biological Problems in Soil Science. Her main scientific interest is role and functions of silicium in the soil plant system, elaboration of technologies for sustainable and organic agriculture and environment protection. She's a specialist in the area of environment pollution by heavy metals and phosphorus, as well as in the area of active silicon effect on plants. Please, doctor, the floor is yours.
Thank you very much for introduction. Good afternoon, ladies and gentlemen. The title of my presentation today, Enhancing Efficiency of Traditional Phosphorus Fertilizer by Silicon-Rich Compounds. As all of you heard many times today, phosphorus fertilizers are one of the most important agrochemicals in modern agriculture. And since 1960, phosphorus annual production was increasing very fast, and at present, Africa and Asia are the main phosphorus producer in the world. The analysis of agricultural use of phosphorus fertilizers shows that in the future, the demand for phosphorus fertilizer will increase with average annual change almost 2%. Among the major plant mineral nutrients, phosphorus is considered to be the one with the smallest world resources. So it is critically important to enhance efficiency of agricultural use of phosphorus fertilizers. The efficiency of this type of fertilizers is limited in the soil, is limited by two main reasons. First, strong chemical fixation of phosphorus in the soil by calcium or magnesium in neutral or alkaline conditions, and by aluminum and iron in acid and neutral conditions. And another reason is phosphorus leaching from sandy soils. Phosphorus leaching from sandy soils can reach up 80% and more. As a result, the soils loses plant available phosphorus, and the efficiency of applied phosphorus fertilizers drops. And another problem being related with phosphorus fertilizer application is attendant pollution by heavy metals present in phosphate rock. It is interesting that numerous investigations have demonstrated that application of the silicon-rich soil amendments or silicon fertilizer benefits the phosphorus fertilizer efficiency. First research on this subject was conducted at the Rothamsted experimental station in England, the first official agricultural station in the world. Their first field experiment with application of sodium silicate started in 1865, and the results of this experiment has shown the possibility to increase the soil plant available phosphorus by application of sodium silicate. Hall, being director of Rothamsted Station in the end of 19th century and in the beginning of the 20th century, and his colleague Morrison suggested the hypothesis of exchange reaction between silicate anion and phosphate anion under silicon fertilization. The results of the sodium silicate effect on phosphorus mobility in the soil was first published in 1906. And later, it was determined that various silicon fertilizers, such as amorphous silicon dioxide, silica gel, silicates of calcium, potassium, sodium, can increase the amount of mobile phosphorus in the soils. Since 1906, several mechanisms of the silicon-phosphorus interactions in the soils have been hypothesized. For example, a Russian professor Ashkenazi in 1937 suggested that anion of silicic acid can replace phosphate anion from slightly soluble phosphates of calcium, aluminum, and iron. Silicon fertilizer applied to soil first increased the concentration of monosilicic acid in the soil solution and its absorption on difficultly soluble phosphates of calcium, aluminum, iron, or magnesium. And the next step of interaction is exchange reaction between phosphate anion and silicate anion. Our thermodynamic calculations have shown that the reaction of displacing phosphate anion by silicate anion from slightly soluble phosphates and the formation of the corresponding silicates is possible. And this reaction proceeds more intensively at neutral or alkaline pH levels. Model experiments conducted with poor chemicals have demonstrated that if we add different concentration of monosilicic acid into the system containing, in this case, hydrophosphate of calcium, the solubility of hydrophosphate of calcium remarkably increases on phosphorus. And you can see, especially at high concentration of monosilicic acid in the solution. Besides monosilicic acid, different types of silicon-rich substances can be added, which are able to release monosilicic acid into solution. And Finally, this leads to raising the concentration of phosphorus in the solution. This effect of monosilicic acid mostly and directly depends on its concentration in the solution. You can see when we increase the concentration of phosphorus in the solution increase very remarkably. And if we tell about solid silicon compounds, their efficiency depends on their ability to release monosilicic acid into the solution. This investigation were conducted with solutions. Of course, soil is much more complicated system if compared with solution. So the main aim of our research was to demonstrate the effect of silicon fertilizers or silicon-based soil amendments on the phosphorus behavior in the soil plant system under different soil climatic conditions. Field trials were conducted in Australia, China, Russia, and USA with different types of phosphorus fertilizers and different types of silicon fertilizers. In Australia, field tests were conducted in North Queensland. As phosphorus fertilizer, we used triple superphosphate at rate 150 kilos per hectare. As silicon fertilizer, we used diatomite at rate 1 ton per hectare. And during 2008-2010, field tests were conducted on 150 commercial fields located on the northeast of Australia and planted with sugarcane, hay, potato, banana, corn, and tropical fruits. And each field trial included at least 3 control plots and with application of conventional mineral fertilizers and at least 3 plots treated with conventional mineral fertilizers plus diatomite. All these experiments have shown high effect of the application on plant growth. And most field tests there were conducted for sugarcane. Generally, diatomite application increased the crop productivity of sugarcane by 5 to 40% and increased sugar content in sugarcane. For potatoes by 10 to 30%. For banana by 15 to 25%, and for hay by 25 to 50%. And you can see that soil plant available phosphorus was increased as well under the application. In China, field tests were conducted in the Hunan province. As phosphorus fertilizer, we used diammonium phosphate and at a rate of 250 kilos per hectare. As silicon fertilizer, we used slag. This is blast furnace local slag from iron production. diatomite from Australia at rate 1 ton per hectare. A slag, this is the same slag, but activated by special treatment with colloidal silicon. And C-Agra, this is a commercial silicon fertilizer from Norway. A-slag and C-Agra were applied at a rate 500 kilos per hectare. And here you can see a test field in China, plots with different types of fertilizer were separated by special barriers to prevent interaction between each others. And in China, our tests were conducted on rice. And here you can see some results of the field test in China. Silicon fertilizer increased rice yield from 4.8 to 7.8 ton per hectare, and water extractable phosphorus and 1,0 point chloric acid extractable phosphorus in the soil were increased as well, and in results, total phosphorus in plant tissue of rice plants also was increased. For example, here without silicon application and this with silicon application. In Russia, field test was conducted in Moscow region on sodium-podzolic soil. As phosphorus fertilizer, we used a superphosphate at a rate 50 kilos per hectare, and as silicon fertilizer, we used amorphous silicon dioxide at different rates, and plant crop was barley. Here you can see a picture of our experiments. Application of amorphous silicon dioxide increased barley yield from 4.3 to 5.2 ton per hectare, and increase water extractable phosphorus and acid extractable phosphorus and total phosphorus in plant tissue. The silicon effect on phosphorus status in the soil plant system was enhanced with increasing amorphous silicon dioxide application rate. By this means, additional active forms of silicon in the soil was positively related to soil plant available phosphorus. And this relation corresponds to our theoretical investigations. And last area with our field test was the USA, Florida. There we, as a source of phosphorus, we use cow manure at a rate 5 ton per hectare, and as a source of silicon compounds, we use calcium silicate slag from Pennsylvania Metallurgical Enterprise at a rate of 1 ton per hectare. In Florida, the main phosphorus problem is related to low absorption capacity of sandy soils. As a result, about 70 to 80% of applied phosphorus is leached into natural waters, rivers, lakes, where, as all of you know, excessive phosphorus initiates the eutrophication, which has a negative influence on fish and other habitats. In the USA, we conducted column, greenhouse, and field test. And besides total phosphorus in plant tissue, besides soil, water, and acid extractable phosphorus, we measured leachable phosphorus in lysimeters and different depths. And we received that silicon-rich substances significantly increased the growth of sorghum plants and increased soil plant available phosphorus, while leachable phosphorus, phosphorus leaching through the soil profile was considerably reduced. And higher effect we observed at higher depths in reducing leachable phosphorus. The data of these experiments evidence that silicon-rich substances had a significant effect on the mobility and bioavailability of applied phosphorus in all tested soil plant systems located in various climatic zones from boreal to subtropical and being characterized by different soil pH level from 5.8 to 8.1 and different soil compositions from sand to clay. And now conclusions. Application of the silicon-rich materials together with phosphorus fertilizers significantly increases the efficiency of phosphorus fertilizers. There are the following mechanisms to explain this effect. With increasing monosilicic acid in the soil solution, the reaction between calcium, aluminum, or iron phosphates and soluble forms of silicon proceed, and resulting in the formation of slightly soluble silicate and increasing soluble phosphorus. The silicon-rich soil amendment can initiate the physical adsorption of phosphate anions from the soil solution, thus reducing phosphorus leaching from sandy soils, but it is extremely important keeping phosphorus in plant-available forms. And both these mechanisms can work together in different soil climatic conditions. And I would like to thank the organizing committee of this symposium for the opportunity of my participation here, and thank you for attention.
Thank you, Dr. Boshadnikova, for this insightful trip all around the world through these concrete experimentations which figure out the impact of especially silicon interaction with P to increase the efficiency. And maybe it could inspire another experimentation for the African continent, which is missing on the map. And it's a small sign to our R&D colleagues from OCP, which could take the initiatives. The third session will highlight the impact of the fertility mapping on the sustainability and the productivity of a crop with a concrete field research on cacao a strategic contributor to the country GDP in Ivory Coast. This research was conducted by Dr. Kofi Emmanuel Cassin, a researcher in the Centre National de la Recherche Agronomique. He is an expert in sustainable soil and water management, and his research in the cocoa farming system focuses on identifying favorable soil for cocoa in a context of climate change and the sustainable management of soil's fertility and the cocoa by the use of mineral and organic fertilizers. He is also interested in the contribution of trees in cocoa tree systems. Dr. Cassin, the floor is yours.
Thank you for the presentation. Good afternoon. My presentation is on soil fertility mapping and fertilizer recommendation in the cocoa belt of Côte d'Ivoire. The study is conducted through the IDH project from 2014 to 2016. And this project is co-founded by OCP in Côte d'Ivoire. My presentation is focused on these points shown in the slide, context and justification, objectives and expected results, materials and methods, results discussion, and next step. An introduction, so we know that cocoa is an important crop for Côte d'Ivoire. The production of cocoa is about 40% of exportation of the country. It contributes to 13% of GDP. Despite this performance, cocoa sector is faced to some constraints like soil degradation through acidification and depletion for nutrients in the soil. In consequence of this is the low yield and the decrease of surface cultivation by cocoa due to abandonment of unproductive plots. For what I just said, we can say that degradation is one of the major constraints of cocoa durability in Côte d'Ivoire. So restoration of soil fertility through fertilization adapted to different types of soil is the key for cocoa sustainability in current agro-pedoclimatic context of Côte d'Ivoire. To do that, it is important to know how is the fertility level at the present. So we conduct the study to make the diagnostic of soil fertility. The main objective is to determine cocoa nutrients need adapted to the soil fertility level. In specific objective is to develop the soil fertility map on the cocoa in the main cocoa production area and to make a fertilizer recommendation adapted to the soil. Expected result is the soil map, the soil fertility map, and with a fertilizer recommendation map. Material and methods. The study was carried out in the cocoa belt with a total surface equal to 1,048 kilometers square, 1,000 kilometers square. The climate is tropical. Average temperature is between 26 to 40 centigrade. Hygrometry is between 80% to 90%. We have 2 rainy seasons with total annual rainfall between 1.2 thousand millimeter to 2.0 millimeter. The method we developed to achieve the goal of the study, we have 5 steps. the first step is to determine the agroclimatic zone of a cocoa belt based on the total annual rainfall and the temperature. For rainfall, we have 3 zones. We have a zone which is not suitable for cocoa with rainfall, total annual rainfall less than 1.20,000 millimeter. We have a moderately suitable cocoa zone, which total annual rainfall is between 1.2 millimeter to 1.4 thousand millimeter. For the temperature, we have also 3 zones. Not suitable zone with temperature less than 26 degrees. Suitable of cocoa zone with temperature is between 26 and 27 degrees centigrade, and not suitable cocoa zone with temperature is more than 27 degrees. The next step is to determine the land unit by combining the geological information, the soil information, and the climate information just I talked about. And this map shows the total land units we have in the cocoa belts in Côte d'Ivoire. The following step is now to take sample per land unit. So in the total, the whole cocoa belts, we have about 575 composite samples. Each composite sample is composed by 30 elementary samples. Samples are carried out in the first 20 centimeters of the soil, where we have more than about 40% of absorbent cocoa roots. These samples were analyzed using the usual and conventional methods described by Batlo and Al 2013. This analysis concerns the pH, the N, the carbon organic, the variable P, the K, the calcium, magnesium, and the extinguible capacity. The following step is now to estimate the cocoa nutrient needs regarding to the result of the soil analysis. So the first step is compare what we have by the analysis of soil sample to the threshold and ratio defined by Jardine and Snook, we shown in the table we have. For example, for the ratio Cn, it must be equal to 2. And the total nitrogen will be between 0.2 and 0.4. Sorry. So as a result, we have a map of the need of N. Our study show that 82% of the soil are poor in N. N is less than 2.0. The need of N is high in this part of the central part of the cocoa belt. We call in Côte d'Ivoire in French the V-Baoulé. And also in the west part, southwest part of the country, and also the east part and the west part of the country. For the need of P, this map shows the need of P. About 81% of soil are poor in available P. And when we take in account the ratio NP, we constate that 96% of soil will positively respond to phosphorus fertilizer. It's the same we do the same for potassium. Our study show that 34% of soil are poor in potassium. And when we take count the ratio potassium and the total exchangeable base, we have 69% of soil which respond positively to potassic fertilizer. For calcium, 61% are deficient in calcium, of soil are deficient in calcium. And based on the ratio, when consider the ratio calcium and the extinguishable base, we have 46% of soil which respond to CR fertilizer. For magnesium, the map shows that 37% of soil are poor in magnesium, and 55% of soil will respond positively to magnesium fertilizer apply. For the pH, about 23% of soil have a pH lower than 5.5. In blue, this part of the country have pH on the threshold of 5.5. What can we say about the result we have? We can see that this map shows that the nutrient requirements have evolved and are not fully consistent with the current fertilizer recommendation dating back from the 1970 centuries. This formulate is NPK 023 and 19 is without nitrogen. And our results show that it's possible now to add nitrogen in fertilizer for cocoa in Côte d'Ivoire. Also, the need of potassium, calcium, and magnesium have increased. In order to restore the fertility of the soil and compensate nutrient uptake by harvesting, we have proposed, through our research, 6 hypotheses of formulates, but these formulates are only based on major nutrients and the soil acidity. So we have 4 of these formulates which are without nitrogen, and we have 2 in yellow, with which we are nitrogen, which need nitrogen. For the next step, we have proposed 6 hypotheses of formulate. This formulate must be must be evaluated through trial for the efficiency and the rentability for farmers. Thank you for your attention.
Thank you, Dr. Kassan, for this insightful testimonial from Ivory Coast. It's really a pride to know that many continents in Africa are walking the talk and are really building the key pillars of a sustainable agriculture, which is a fertility map. Last session, last but not least, the 4th presentation will share with us how fertilizers could contribute to solutions for malnutrition. It will be done by Dr. Samuel Gameda, who is a senior research fellow fellow at the International Food Policy Research Institute. He used to be a director at the Ethiopian Agricultural Transformation Agency. He's got a PhD from McGill University in Agricultural Engineering and Soil Sciences. Please, doctor, the floor is yours.
Good afternoon, or should I say good evening. I guess I'm the last person to stand between you and what plans you have. I'll try to be as brief as possible. Okay, so we have spoken about nutrient management and we've spoken about it in the context of what we need for crop production. But there is an aspect of it that can be also of use to human nutrition. And I will focus for most of my presentation on zinc and what precipitated some of the work that we were doing was, again, as was mentioned earlier, the work on some soil fertility mapping. So how is it that we can use nutrients for both crop production, but also for human nutrition? So if you look at zinc, it's a very important part of the metabolism in human beings. It's an important thing. The lack of zinc or the deficiency in zinc has implications, particularly in children, in mortality and morbidity, in respiratory illnesses, and it can result in problems of growth, both physically and also mentally, and has significant impact globally. It also has an impact on childbearing women and can lead to preterm delivery in pregnant women. As I said, it's an important issue globally. If we look at it in the context of Africa, it's in the order of a quarter of the population that is affected by zinc deficiency. So it's a substantial problem. So, and in terms of deficiencies in soils, there's a lot of belts within the global soil, agricultural soil, that have significant deficiencies in soil zinc as one of the nutrients. And within the context of Ethiopia, we found when we're involved in the mapping of the Ethiopian Soil Information System that over half of the agricultural land is impacted by zinc deficiencies. In some regions, it's upwards of 70%. And to show you a map of this, the red signifies the area within the country that shows deficiencies in zinc, the yellow showing borderline contexts. So the question that we had to this is, how much is it contributing to the problem that we have in zinc deficiencies in the human population, and to what extent can we start addressing it from the context of malnutrition? And how cost effective will it be? We did some preliminary studies just looking at some data sets. So if we're looking at zinc status in the human population under a project, Feed the Future, some of the studies that we did, including feeding and stunting, we found that there were some associations between the location of the zinc deficiencies as well as the location of the occurrence of stunting. So under, for example, cereal production systems, we saw that the areas, if you look at the left-hand side, where you have zinc deficiency, the stunting is higher than in areas where there is sufficient amount of zinc. If you looked at particularly wheat production systems, it was even more pronounced, anywhere close to 55% down to about 45%, so a 10% spread in areas. So there's some associations. We can't quite say they're attributions, but there are effects associated with this. So the strategies generally associated with addressing for example, these types of malnutrition problems are through things like supplementation and fortification and things like that. And also a behavior change where you try to have diversified diets and things like that. In terms of some of the interventions, the effectiveness of these ones really impacts greater urban and basically like factory-based type populations than it does rural populations. Most of the food consumed in rural areas is produced by the same people that consume them. So they don't go through industrial processes where you can add fortification or you can use other strategies like that. So in areas like this, and particularly if they're also using fertilizers in their production systems, there is the opportunity of what we call biofortification. And there are two types, but one is the genetic one where we actually try to increase the amount of known nutrients or nutrients needed within the crop itself, or the other, what we call agronomic biofortifications, where we use it through a process of adding the nutrients either through basal fertilizers, foliar applications, or the like. And these things, and that process can address deficiencies that are there with existing crops, and there's a possibility to have a response fairly quickly. So from the context of Ethiopia, where we're seeing, okay, can we do this? And particularly in the context of what's happening in the fertilizer industry right now, is that feasible? These types of things have been addressed, wheat production in the Anatolia region in Turkey, rice production in India, maize production in Zimbabwe. They have actually shown how agronomic biofortification can really enhance both productivity and the nutrient content of these crops. So I think I'll skip through most of this, but these are some of the questions that we're trying to address in the process of trying to do what some of the studies that I'll go into fairly quickly. So as I said, in the Ethiopian context, there's a policy context now that can facilitate this. There's been the introduction of blended fertilizer facilities, basically to be able to formulate fertilizers targeted to regions on the basis of what types of nutrients are needed for those regions from the maps that we have. But this can also be enhanced to be able to address malnutrition or micronutrient requirement challenges. So there is the potential to be able to have a policy take-up of something like this if we can show that we can be impactful. So again, in terms of setting this up, we did these studies both on the basis of laboratory studies in pots and also in fields, on farmers' fields, where we added applications on farmer practices. So to show you some of the results, the impact that we had on the studies that we're doing in potted plants, maize, showed that the impact on yield, and I think there were some limitations in how we structured the experiment, but the impact on yields was really between no fertilizer and fertilizer rather than the different types of fertilizer. But if you look at the zinc content within, the highest one that we got was from the application of basal zinc sulfate amounts with also side dressing of zinc. But also a basal application with foliar also gave you a substantial amount. So the application of zinc fertilizers, both in terms of basal applications and foliar applications, as well as side dressing, substantially increased the amount of zinc that the grain had as compared to the standard practice that we've had in the past, which was, until recently, it was actually DAP and urea. Now it's NPS plus urea. So the potential for this is promising. And then this basically shows you some of the structure that we had in this. I just went through the results for you. And if we look at actually the leaf part, or the biomass part of it, there was also substantial impact on that. And this can have impact on in terms of fodder and therefore livestock production as well. So again, it's not just the grain, but it's the total crop zinc content that is impacted by these applications. So it's very promising. The field trials that we did, we basically, the results that we have is from 2015, but we basically applied foliar zinc sulfate to farmers' practices, and we found, if you look at the black dots, that's where the zinc content of foliar applicated plants or crops. And so we were getting in wheat and in also in teff and barley production, for a majority of the cases, an increase in the zinc content, in the grain zinc content of these crops on farmers' fields. So the potential for it is great. So to summarize this then, the use of blended zinc sulfate in basal application as well as in foliar application will increase grain yield, increases grain yield, and the potential that this has for both application for human nutrition, but also for livestock nutrition as well, is fairly high. We've also, with my colleague Limulaye Sise of OCP here, been doing some studies on the use of these micronutrients in production in other parts, in rice production in Côte d'Ivoire and in maize in Kenya, and some of the preliminary findings that we have, I just want to go through quickly with you here. What it shows, don't have a pointer. What it shows primarily is for a number of the plant components that, what's it? Oh, okay, this, it is possible to, which one is this? Is this? Wait. Okay, anyway, for a number of these, the use of zinc along with NPK compared to basically no fertilizer treatment basically has improved but not always differentiated impacts. But when you look at yield, it has substantive amounts of impacts on the productivity of rice, in this case, under irrigated conditions. And if you look at the use of zinc and iron in rain-fed conditions, you're finding again that you had improvements from the addition of iron and zinc. In this particular case, in most cases, the use of iron outweighed the use of zinc, but the use of both combined was higher than, substantially higher than the use of each individually. So we haven't yet looked at the grain zinc content of these at this point, but we expect to see, and in this case iron, but we expect to see improved grain content of these nutrients within the grain of both rice and maize. The results for maize, we're still waiting to incorporate into this, but they should be in the paper. So, and then this is just a quick picture of some of the work that we found for rice in Côte d'Ivoire. And so, in summarizing then, these micronutrients have an impact on crop yields, and we expect them to have an impact also on zinc content, zinc and iron content, and therefore potential impact on human nutrition. And we expect going forward to be able to actually see over time to quantify what these impacts are from agronomic biofortification. So basically to conclude, you can say that micronutrient-containing fertilizers have a significant on-crop production, but also have the potential to address human nutrition needs. So I think one of the things to consider within fertilizer production systems is that what is the impact that it can have not just on crop nutrition, crop productivity, but in contributing to the malnutrition burden that exists globally. Thank you.
Thank you, Dr. Gameda, for this insightful lightning on the impact of zinc on the increase of productivity. Before asking Dr. Ralos for a wrap-up of this session, we will take maybe 2 rounds of questions. I will kindly ask the organization for some available micro. So please, we have a question over there. Micro.
Hello, my name is Baba Shola Jiboye, and I'm going to make my question very brief. It's to the last speaker, Sam Gameda. I'm really happy to see zinc biofortification effort taking off in Africa. And the question that I have is the grain content of zinc that you have. Is it the total zinc in the all parts of the grain or the edible part of the grain? And the second one is related to the timing of your foliar zinc application, if you are actually considering any mechanism in formulating that zinc so that the zinc that you're applying foliarly is actually being taken up by the crop. Thanks.
Maybe another question? Excuse me.
Thank you. My name is Martin Jemo. My question is to go to the last speakers. Normally, there are 2 approaches of fertilization, providing nutrition to zinc. People are talking about biofortification or soil apply. And in theory, the success of biofortification has not been gone through. So, what could be? I mean, there are 2 theories. Which one is suitable in the context of Africa where many are zinc depleted?
Could you present yourself, please?
Martin Jemo, OCP. I'm saying that you want me to repeat the question?
Yes,
please. So I'm saying that in the literature, there are 2 approaches. Either you go for biofortification to enrich the crop, or a cultivar, a generator with zinc, zinc. What people are talking about biofortification, and or you go for soil apply, believe that it will be taken up from the soil and play the same role. So in the context of that, we know that many soil in Africa are nutrient, including zinc depleted. What would be the suitable approach to resolve that zinc problem and malnutrition consequently into human being?
Thank you. Third question.
Hello, hello. Yeah, Zheng Lihe, and from University of Florida. I have a question to Dr. Jose and the first speaker, I believe. And you have reported some very interesting results. And I mean, PR, direct use of PR has been practicing for over 50 years. However, you take a consideration of economic component. That's very good, I think. But I have one simple question and one comment. The question is that what is the particular size of the PR material did you use?
Okay. Thank you. Dr. Mjahid?
I will have another comment. And can you answer my question? What's the particular size?
We will come up with the answer.
No, I have
Sir,
comments.
we will come up with the answer after the fourth question, please.
Okay, and I have another comment then. Let me finish, okay?
Okay.
Yeah, my comment is that I noticed that when you apply the PR material, you also apply the manure and apply the lime. I can understand the benefit of manure application. However, I just wonder why you want to add lime together with PR, because PR itself already has some liming capacity. In addition, manure will also prevent the aluminum toxicity. So I wonder what's the benefit for, the use of lime together with PR. That's my comment.
Thank you. Dr. Mjahid?
Khalil Mjahid, for professor at the University of Mohammed VI Polytechnic. I have two questions. First one is for Dr. Elena. Is the application of silica along with fertilizer, phosphorus fertilizer, economically justified? Is it economically justified? Is it economic? And second question is for Dr. Kofi. When you established the soil fertility map for different elements, you chose some levels, for example, phosphorus 12, potassium 0.2, something like this. How did you choose these levels? Did you have any response trials, something like this, in order to come up with critical levels that you used to judge the soil fertility, or just from literature? Thank you.
Thank you. We will have another round of questions. We will maybe ask our honorable guests to come up with maybe some clarification. First, Dr. Gameda, for the two first questions regarding zinc and the time of apply.
Okay. Thank you for your questions. The first question regarding zinc content in the grain, it was looking at the total grain and not just the edible part. Another aspect to consider about this, one of the issues with particularly zinc is the bioavailability of it from cereal grains. So there's still a lot of work that needs to be done, so the bioavailability of it can be much smaller than the total amount that's there. In terms of the foliar application for zinc, in maize we were applying it at the 5-leaf stage. Yes, it does make a difference, and there are studies in terms of timing and how that incorporates either into the grain or into the total biomass production. The second question was around biofortification as to, from my understanding, between genetic and agronomic. I think there are a lot of developments in genetic improvements and increases in, for example, orange sweet potato and vitamin A, iron and zinc and a couple of crops. I think those are important things, and they're definitely a direction that needs to be taken that's going to address things. However, for example, even a zinc-fortified crop requires zinc from the soil. It does not create the amount of zinc out of nowhere. So I think you need a complementary approach to each of these. That's one. The second is, in the short term, you can start using these nutrients in your soil right away, whereas when you're waiting for biofortified crops, it will take a number of years before it's in place. I believe those were the only two questions to me.
Yes. Dr. Hosnain?
Thank you for the question. The first comment of your comment, in Indonesia, we don't have a phosphate source, actually. We have a limited number of deposits, but it is not the high quality of rock phosphate. So we usually use soluble phosphate as like we have a TSP or 36% P2O5. We call it SP36. So the use of phosphate rock in Indonesia also is not very common. We only use it for oil palm plantation at the replanting for the first time, only 500 grams. So you can imagine that it's very costly if you use a soluble one in the acid soils. So that's why in this study, we try to scaling up our results, and from the past we did also in the 90 active start from 89 as you see in the presentation, but it is not commonly used as like in China. In China, maybe you have the large deposit also. For the particle size, maybe Dr. Abdurrahim Nasir can answer, because he has he's the one to send the rock phosphate to Indonesia.
Excellent. Dr. Borshakinoglu?
If tell about economical issue of silicon fertilization, there are at present, there are a lot of different silicon fertilizer on sale. There are liquid silicon fertilizer, there are solid silicon fertilizer, natural minerals like diatomite, like zeolite, and slag-based silicon fertilizer. And of course, price for all these fertilizer very different. For example, if tell about liquid silicon fertilizer, in some our experiments we used American liquid silicon fertilizer. It represents concentrated solution of monosilicic acid containing about 18–20% of silicon. And in our experiments, this liquid silicon fertilizer, we diluted in a proportion of 1 to 1,000 times. Price of this liquid silicon fertilizer about $10 per liter. If tell about solid silicon fertilizer, like natural minerals, diatomite, zeolite, price about several $100 per ton. And of course, their price mostly depends on transportation, on distance. And we have many other choices for using different industrial metallurgical slags. For example, in Florida, they used metallurgical slag from iron production. Of course, cost for slags is not high. And again, depends on distance on transportation. If tell about rates of silicon fertilizer, mostly if this is silicon-based slags, they applied at rate several tons per hectare. But there are some advanced silicon fertilizer which application rates about several hundred kilos per hectare. So we have so many possibilities, and every time we need search for local material, for cheaper sources, and it will be more profitable for farmers.
Thank you. Dr. Nasir, would you like to add some comments to the question answered by Dr. Hussein? It's okay, it's working. It's working.
Okay. My name is Nasir, I'm from OCP Singapore. So as a co-author for the paper presented by Dr. Hussein, just would like to answer the question about the particle size. So the rock phosphate from OCP used in this experiment, the particle size for the screen greater than 701, 10% is going through. Between 175 and 701, 40% is going through. And less than 175 micron, the 49% of the particle size is going through. Just to add that this rock phosphate our rock phosphate, reactive 1, meet the requirement of what we call the SNI in Indonesia, which is the standard national of Indonesia. So you have to meet this kind of requirement. It's not only the particle size, but other like reactivity, citric solubility, and the P2O5, and other criteria. But in terms of particle size, what I'm giving you as a result is our rock meet the criteria to be used as reactive rock phosphate for direct application.
Thank you. There were last question for Dr. Kassan.
Okay, thank you for your question. What I can say is that in our approach, we use levels we shown in our presentation just to know if the nutrient is sufficient or no in the soil. When the nutrient is deficient in the soil, we use another method, the diagnostic method, which is a tool built by Jardine through several annual trials. The target of this, the target or we use in this method is 1 ton. And we calculate, we compute it, the nutrient we need to achieve these yields and to compensate uptake of nutrients and the deficiency of the soil in a particular nutrient.
Thank you. Maybe 1 or 2 last questions?
Okay. Good evening.
It's okay, it's okay.
Good evening, everybody. I would like to, my name is Khalid Al-Ruhali. I am from SABIC, Saudi Basic Industrial Corporation. Actually, I want to thank all the speakers for the good information and good presentation. I have just one comment to Dr. Elena. This is actually, honestly, this is the first time I heard about phosphorus leaching. It has been proven since years and years in the literature review that phosphorus movement in the soil is very slow. So we don't hear about phosphorus leaching, even in the very light soil, in the sandy soil. Thank you.
Thank you. I guess it's more comment than a question. I will kindly ask if there are no more questions. I'll kindly ask Dr. Mohamed Al-Gharous for a wrap-up of this session before thanking warmly our guests. Do you want to have? Yes, please. As you like. Do you want a micro? Do you have a micro? Okay.
Well, thank you, Chair.
I would like, first of all, I would like to thank our speakers for their valuable presentation and the results that they shared with us. In fact, during this session, we have learned from our first speaker that the use of reactive rock phosphate in combination with manure and lime increased yield of maize and oil palm, and also had a residual effect of more than 4 to 5 cropping season. It also has contributed to improving the soil health by increasing carbon content in the soil. Our second speaker has shown to us a new technology of interaction between silicon and phosphorus fertilizers to decrease phosphorus leaching in sandy soils, and also to convert the P fixed with aluminum, calcium, and into valuable forms. Our third speaker shared with us that soil testing conducted in Ivory Coast in the cacao production areas have stressed the low soil fertility in this area, and the data used, this data was used in combination with cacao needs or nutrient needs to propose different fertilizer formulas for the production of cacao in this area. Our fourth speaker has shown to us that malnutrition, the studies conducted on malnutrition or human malnutrition, it is in relation to the low level of micronutrients in soil. Therefore, the use of fertilizer fortified with micronutrients, especially iron, especially zinc, and iron, maybe boron, are beneficial not only for crop nutrition but also for human and livestock nutrition. So by this, I just finished this wrap up of this session. I give you the floor to close the session and.
Thank you, Dr. Lados.
Thank you.
Thank you. Just join me to thank warmly our 4 speakers and to thank the organization for this meeting, and hope to keep this community for the follow-up beyond the SYMPHOS events. Thank you.
Thanks a lot for following, and we see you tomorrow. Thank you. Well, that's it for the first day of SYMPHOS here at Bengrir, and we've had a great time with all these attendees and with you online, and well, we're really excited to see you again tomorrow and the day after for more discoveries, and tune in to our live feed on YouTube and on LinkedIn. And also, don't forget to tweet at us if you have any questions, any remarks, anything you want to share with us. Use hashtag #SymphosLive. Hashtag #SymphosLive. Thanks a lot for following, and we see you tomorrow. Thank you. Well, that's it for the first day of SYMPHOS here at Bengrir, and we've had a great time with all these attendees and with you online, and well, we're really excited to see you. To tweet at us if you have any questions, any remarks, anything you want to share with us. Use hashtag #SymphosLive. Hashtag #SymphosLive. Thanks a lot for following, and we see you tomorrow. Thank you. Well, SYMPHOS here at Bengrir, and we've had a great time with all these attendees. Well, that's it for the first day of SYMPHOS here at Bengrir, and we've had a great time with all these attendees and with you online, and well, we're really excited to see you again tomorrow and the day after for more discoveries, and tune in to our live feed on YouTube and on LinkedIn. And also, don't forget to tweet at us if you have any questions, any remarks, anything you want to share with us. Use hashtag #SymphosLive. Hashtag #SymphosLive. Thanks a lot for following, and we see you tomorrow. Thank you. Well, that's it for the first day of SYMPHOS here at Bengrir, and we've had a great time with all these attendees and with you online, and well, we're really excited to see you again tomorrow and the day after for more discoveries, and tune in to our live feed on YouTube and on LinkedIn.